Hello everyone, welcome to this course which is all about helping you to become an advanced blockchain developer. And in this course we are going to build something meaningful. So in this lecture I am going to give you all around introduction to this course. So first of all, let me introduce myself. So I am Rohit Sonone and this is my LinkedIn profile that you can go and check. I have 7 years of experience in software development and consulting. And for past several months I am mostly involved in a blockchain consulting and programming, and I am an expertise in cryptocurrencies and Solidity Ethereum smart contracts. I also work with the Web3.js libraries Truffle and Remix. Okay, so before we start into this course within the next lecture, I just want to make sure that you're aware of the key things that you will be required for this course. I have structured it in a way which is well paced for everyone to ensure they feel fully comfortable. By the end of this course, we are developing with the good applications in a blockchain. Okay, in this course we are going to see the workflows and setup and configuration needed, okay, and the ecosystem of a blockchain. Also we are going to write down some test cases for our token system using Truffle test framework. After that we are also working with the front end with the React.js, so in which, and that is very important thing that we are going to look in this course. So using Web3.js we are connecting the Solidity and front end. So Web3.js is a library, so that we are also look at in this course. After that we are also going to look at the test network like Ganache or Rinky B test network, and understanding how to use the distributed applications and much more things. Pretty soon you will probably not have had enough time to work through the lectures at that point, so don't feel obliged to leave a review if you haven't covered enough of the course. Of course, reviews are always welcome, so if you are happy, please leave us a feedback. But if you want to work for more of the course, please do so before leaving early reviews, and you will be prompted later in this course again for the reviews. That's everything was for this lecture. I just wanted to give you an introduction to this course before we dive straight into the next sections. So in this course we are going to look at ERC 875 Ethereum protocol for non-fungible token. So for more information you can Google it, ERC 875 non-fungible token. So here are some links that you can go and check here. Okay, so ERC 875 is a non-fungible tokens, okay, with simple atomic swaps. So if you are aware of previous ERC based protocols like ERC 20 and ERC 721, that time you know that ERC 20 is a simple fungible tokens, means all the tokens are the same. Okay, after that they came up with the ERC team came up with the ERC 721 protocol, and that is for non-fungible tokens, means the tokens, every token is different from each other. So but there are some problems, so to tackle those problems they come up with the ERC 875 protocol, and this is also a non-fungible tokens protocol with the simple atomic swaps you can see here. So what is the atomic swap and what is the difference between ERC 875 and ERC 721, that we are going to look in this course also in details. But for the introduction, you can go to the trade function here. Okay, and this is the difference, the main difference between ERC 721 and ERC 875. So the difference is that a function, this function actually allows to sell a batch of non-fungible tokens without paying the gas fee. Okay, means that you don't have to pay gas for every token that you transfer. Okay, the seller does not need to pay the gas. Okay, only buyer need to pay the gas. So, and you can sell the bunch of tokens in this system using this trade function. So that that things we will look in more detail when we start with the ERC 875 implementation in the next lectures. So but this is the same thing like ERC 721, but just some minor differences is there. Okay, for the full interface you can find their main GitHub page. So find just GitHub page on internet and you will find this is the contract. So here are some summary and the functions things you can see here. So this is the thing that we are going to look in this course. So for more information you can always go to the Google and find the more detail about 875, but I think you don't need to find more details because we are going to cover all the important aspects in this course. We are also going to check these functions like trade and owners of and transfers in the remix in more detail. And in the last lectures we are going to create a front end for some of the functions like balance of and transfer functions. So we will look forward to see you in the next lectures. Thanks for watching. Hello everyone. So in this lecture we are going to see what is a blockchain, and in this session we are going to cover the basics of a blockchain so you can understanding the foundation of a blockchain, so you will understand the future coding and the syntax that we are going to write down in this course. So let me start with the what is a blockchain. So if you're I think if you are doing this course you must probably know what is a blockchain is all about, but let me explain a little bit amount of data for this. So what is a blockchain? So blockchain is a type of a distributed ledger for maintaining a permanent and a tamper-proof record of transactional data. A blockchain function as a decentralized database that is managed by computers belonging to peer-to-peer network. So what is actually this definition is all about? Okay, if we are going to see this slide here, you can see different types of networks here. So this is centralized, decentralized and distributed networks. Okay, these are some new networks that are present right now in the world. So what is the difference between the centralized, decentralized and distributed system? So in centralized system, all you know is that every node or every computer in that network is connected to some centralized system or some centralized server. So that's why it is called a centralized system. So in today's world, many of the systems that we are using over the internet are centralized system. Means that there is some server like for like some Google server at some central location, and we are accessing that central database of a Google from our computer. So that is a centralized system. Then what is meant by decentralized system, and why it is needed to make a network that is decentralized? So the main problem with the centralized system is that if the server goes down, okay, the central point where we are all connected, if that goes down, we cannot communicate with each other, right? If this central system goes down, then this node cannot communicate with this node, right? Because the central system is down and there is no medium through which I can communicate. So to eradicate this problem, the computer engineer come up with this decentralized system. So in this centralized system, as you can see here, there are different types of nodes here, right? And there are some little networks you can see here. Okay, and those little networks are connected to their some centralized smaller server, you can say. Okay, but the decentralized system has also a problem of the failure for particular nodes. Like if this node wants to communicate with this node, okay, but this node goes down, then this node cannot communicate with this node. So this is the problem with the decentralized system. But advantage is only that all the network does not goes down, okay, if there is a failure of some node in the decentralized system. Okay, that is the benefit that we get in the decentralized system. So to eradicate this problem also, the network engineer comes up with the distributed system. So this in the distributed system, as you can see that everything is connected to everything, means every node is connected to every node, and there are multiple routes by which they can communicate with each other, right? So if, for example, if this node wants to talk with this node, okay, and for example, if this node goes down, still this node can communicate through this node with this, right? So in distributed system, the network never goes down, okay, and every node can communicate with each other, and there will be no effect of a particular node if goes down. So network still will be alive. So that is the benefit of the distributed system that we get in distributed network. So what is a blockchain is all about? So blockchain is a decentralized and a distributed at the same time. Okay, so it is a decentralized, so there is no particular central server present in the blockchain, and it is a distributed also, means every node is connected to each and every node through some network over the internet. So if a particular PC goes down or a particular node goes down, still there will be no problem in a blockchain, okay, to get a data or to send a data, right? So this is the main difference between centralized and the blockchain systems, you can say. So as we can see in the next slide also, here you can see the same image with the computers, and the network is a distributed system, right? So here you can see it's a shared public ledger, okay, of transaction. So this is the shared system, it's a public, so anyone can see a data on a blockchain, okay, and a ledger of transactions. So each and every node has updated transactions and ledger, right? So if I download the blockchain node into my computer, I can also see the transactions of a particular person, because blockchain is a public thing, right? So anyone can inspect the transactions. So there is no hidden type of things in a blockchain. So it is all transparent and no single entity controls. So the best beauty of a blockchain is that no a particular company and there is no particular owner for a blockchain system. Means that there is no company, there is nothing that owns this system, okay, and that is the beauty of the blockchain, that no one owns the system and still it goes on, right? So we will look a little bit about history of a blockchain. So where is it come from, and who developed this, and how it came into the existence. So I think we will see these things in the next lecture. For right now, thanks for watching. Hello everyone. So in this lecture we are continuing with the history of a blockchain. So where does it come from, who developed this system? So in 2007, a person named Satoshi Nakamoto begins the working on this concept called Bitcoin, right? In 2008 he published a white paper on a Bitcoin, and after that he started working on this concept called Bitcoin. So as many of you know the Bitcoin and what is a Bitcoin is all about. So Bitcoin is just a cryptocurrency that people trade for fiat currency. Okay, that is just a virtual currency, right? In 2009 there is a first transaction that is happened in the Bitcoin, and after that the Bitcoin journey started from year to year. And as you many of know, in 2017 Bitcoin price is like about $11,000 US dollars. So after that the people got attention about this Bitcoin, and they find out what is the technology behind this, because Bitcoin no company owns the Bitcoin, right? And no person owns the Bitcoin company, right? It is an automated system. So people go to that particular protocol of the Bitcoin, they play that particular game of a Bitcoin, and they get the Bitcoins, and after that they trade that system. And people were amazed to see this system, that no person is involved in this system, only end users are present, but in the system no human interference is there, right? So many of the companies and developers get mesmerized by this concept, and they thought that okay, so this can be possible if we get this technology of a Bitcoin. So they researched about this technology of a Bitcoin, and they found out this the underlying technology of a Bitcoin is a blockchain. So after that they think that okay, so blockchain is the foundation of this Bitcoin, so we can also use this foundation for other problems that are present, and those are present right now in the world, and we can solve this problem by using this blockchain technology. So many of the developers adapted this blockchain technology. They researched for this thing, and they found that this technology is amazing. So from last 2-3 years you will find that many of the applications now are built on this blockchain technology, and in the future you will see many more applications that are going to use this technology, because this is the one of the best technology that you can have. So what are the main companies or the main people that are using this thing, and they are pushing this blockchain technology forward? So the first company is the Ethereum or the network, you can say, that is Ethereum network. So in this course also we are going to use this Ethereum network. So Ethereum networks are blockchain networks, you can say. So Ethereum networks are used to transfer money and store the data. There are many different types of Ethereum networks present in the world right now. So these networks are formed by the nodes, or you can say computers or servers. Okay, and the Ethereum nodes, you can have multiple or many thousands of computers present, right? And each node is a machine running an Ethereum client. So if you have your machine, and if you are running this Ethereum client, then you can also be a part of this Ethereum network. So anyone can run this client on their PC, and they can be a part of this Ethereum network. So, and each node or each PC will contain a full copy of a blockchain, right? So in this course we are also going to see what is actually an Ethereum network and how to use this Ethereum protocol to build distributed applications, right? So before that, let me tell you what is actually a blockchain versus database thing, right? Many of the people get confused about what is a blockchain actually, right? So if you imagine, blockchain is nothing but a database, right? So our front end that you see right now in the world, those are done in HTML or in HTML5, React or AngularJS. Okay, those are also those things which we can use in blockchain also, because at the front end side there is no difference, right? Only at the back end or at a database level there is a difference, right? So we will see what is the main difference between blockchain and database. So first thing is that blockchain and database are same because they save data. Okay, so only difference is that blockchain saves the data in the blocks, okay, and our regular database like in MySQL or MS SQL store the data in a particular centralized data file. Okay, that is the main difference. Okay, but otherwise there is no difference when it comes to saving data on a blockchain or on a database. After that, the flow to store data is the same, right? In a centralized application also, if you want to pull up some data, that time what you do is that you write a query on your computer and you pass that query to your application server, and then your application server query to your database, and you will get the data back from your application server, right? And the same flow is for the blockchain also, because at a blockchain your computer and your application server are present. Okay, just difference is only at this side. Here instead of database, we are you will find there is a blockchain, okay, at the back end. So whenever you want to get a data or you want to store a data, that time you do the same flow that you query for your application server, then your application server query for your blockchain database, and then your blockchain database returns the data to the application server and then to your computer. So the flow is same for your database thing or database based application and the blockchain based application, right? But the huge difference is about the money, because as of many of you know, in the centralized database system or the database that you used nowadays like MongoDB, MySQL, MS SQL, okay, those database does not cost any money, but blockchain cost you a money to save particular data onto a blockchain, right? So this is the huge difference between your blockchain and your regular database, because to store a particular data on a blockchain you need to pay a money. So this is the main difference that you will find between your regular database systems and in your blockchain systems. Okay, so what is the cost of that money and other things we will see in the next lectures. Okay, also a blockchain store a record for every change ever made to its state, right? So in a normal database, okay, whenever you have some data like users and balance, okay, in the same table you change those things at the same place, right, like their balances. But in a blockchain we save every state of the blockchain, right? If you see this slide and in this image, this is the initial state, okay, and this is the balances for this user, okay. When first transaction happened, okay, just you can see here that the bill sent $10 to Alex and Jill sent $30 to Andrew, right? So this is the first transaction. So this transaction is separately saved, okay. So this state is different and this state is different, so both these state are saved in the database, in a blockchain. After that, whatever may be the future transaction, those are also going to save in the blockchain as a separate entity. So whenever you want to check, okay, for a particular transaction a hash or a particular transaction data, you can check what is the current state of that system. So this is the beauty of a blockchain, that you will get each and every transaction, and you can check every transaction on a blockchain, right? So what is a block is all about? So in a blockchain, block is all about memory chunks that you can use to store your data and the private keys for that particular blocks, right? So those are only memory chunks, okay, that you can say blocks. Okay, so if you look at this example, there is always for any blockchain network, there is always a first block called a zero block or a genesis block. Okay, that is a starting point for any blockchain. Okay, so that's why it is called a genesis block, and it has a configuration of a how many coins and how many things it will contain in that block. Okay, so that configuration is present in that genesis block. Okay, and after that, whenever there is some transaction happened on a blockchain, so at that time another block is created. Okay, and in that block, the previous transactions from the previous block is also saved in that new current block, and the current transaction are also saved in that block. Okay, so just like that, for every transaction, this process happened again and again and again and again, and all these blocks are connected to each and every one, okay, in a linear manner, right? So that is why it is a block, that is why it is called a blockchain. Okay, as I told you that about the genesis block, the first block, okay, right? So we can configure it. Okay, so if you want to start your own blockchain network, so that you have to first create this file called genesis.json, and in that file you have to write down some configurations. Okay, and after that you can use that file to start your blockchain network. In the mainnet also, at some point someone has created this block 0 or genesis block at some point of time, you can say. Okay, and you can also develop, or you can also deploy a private blockchain network using this genesis.json in your computer. Okay, you does not need to go to your main network to publish your apps or something that you want to publish every time. You does not need to go to the public server for publishing, right? Because it costs also money. You can also develop your, or you can also deploy your private blockchain in your PC, and you can test and configure your apps over there also. Okay, so this is the beauty of a blockchain. Okay, and as I said that the transaction for every transaction, okay, the blocks get added. So who actually mine these blocks, right? So there are some miners, okay, who mines means they validate the blocks, right? And they validate according to the rules or the consensus of a network. Okay, so the miners are the people who check that, okay, the data that we got from last transaction is okay according to the consensus of this network, and if that is correct, then they get rewarded for that also, for that validating that transaction. So this is the beauty of the blockchain, Ethereum blockchain, or Bitcoin blockchain, you can say. Okay, and the most important thing is on a blockchain is that you can't tamper the data. Okay, the blockchain system is hack-proof system. That's why all around the world now people are using this blockchain technology, because you can't tamper the data on a blockchain, right? For example, let's say this is the blockchain system, and say everybody or every miner is working on a block 91, right? Okay, but one of the miners, okay, wants to alter the transaction block 74, right? He wants to alter this block 74 transaction, right? So what he needs to do, he have to make his change and redo all the computations for blocks from 74 to 90 and do block 91, that is 18 blocks, right? So an expensive computing. So if you want to alter the data on a blockchain, you need very high mainframe computers to alter the data on a blockchain. But in the real world right now, it is not possible for any computer in the world to alter the data on Ethereum based blockchain, because it is a already huge network, okay, and you can't afford to alter those data or those transactions on the Ethereum blockchain or any big blockchain network. So this is the main beauty of a blockchain, that it is unhackable, right? So this is all about the blockchain introduction and the history and what is Ethereum network is all about and things. So we will meet in the next lecture. Thanks for watching. Hello everyone. So in this lecture we are going to see Ethereum history and smart contract. So let's get started with the Ethereum history. So as you can find more information on in the internet, so here is the person called Vitalik Buterin in 2013 published a white paper on Ethereum, okay, and after in the early 2014 Gavin Wood, who described it properly, okay, and after that in 2015 the Ethereum network or Ethereum blockchain, you can say, launched using crowdfunding, right? So this is the just basic history about the Ethereum blockchain. So what is the main difference between the Bitcoin blockchain and the Ethereum blockchain, right? So what are the features that Ethereum blockchain network provides rather than Bitcoin blockchain or other any cryptocurrency related blockchain networks, right? So these are the some features that you can see in the Ethereum, okay. So first is the Solidity thing. So the Solidity is a programming language built for the Ethereum. So you can write a smart contracts, okay, a smart code, you can say, in a Solidity language, okay. So it is a built-in programming in a Ethereum that you can use to write a code. So this is the first feature, you can say, in Ethereum. After that, Ethereum is a Turing complete, so it can simulate a computer, and it is said to be the most expressive. Means that Ethereum network acts like the computer, okay. It runs your code, okay, it saves your data, it get back to your data, it's secure your code and everything just like that. So it is a Turing complete, you can say. After that, a smart contract. So Ethereum network provides us a smart contract, that is a piece of code running on a blockchain. Means that you can write down a program in a Solidity, you can publish that code on this Ethereum network, and you can interact with that code, and that code is called a smart contracts in the language of Ethereum, right? After that, Ethereum provides us a corruption and tamper-proof system, right? So apps based on the network are formed around the principle of consensus, so making the censorship impossible. And because of the consensus algorithm, there is no problem of the corruption in the system, right? So everyone needs to agree on a particular validation, and then that transaction or that particular data will be saved on that Ethereum network. So that is the beauty of this Ethereum blockchain. After that, it is secure, so with no central point of failure, right? So it is secure, you can say, and all the data on a blockchain is cryptographically signed, so that if there is a problem of hacking happened, okay, if someone gets a piece of a blocks from the blockchain, and if he trying to encrypt or decrypt that block, he will not be able to do that, because the data on a blockchain is stored in a cryptography. So he will only see a number of digits and nothing else, right? So that is the best thing, that it is a secure. After that, immutability. So objects code can never be changed. So when you save your smart contract or some data on a blockchain, so it never gets changed by anyone, or it will never change. So that is the thing. After zero downtime, so your apps never go down, okay, or can never be switched off, because as you know, Ethereum network is a blockchain system. So if one node goes down, or if one node goes switched off, still there are other nodes, those have the same copy of that data that you can get from those nodes also. So this is the best thing also. After that, this is a truly global, so you can say the one computer for the entire planet that never goes off, right? So it is a truly global. After that, the ethers. So this is the main crypto fuel, okay, in which we need to pay for gas, okay, to save the data on Ethereum network. So this is the currency or cryptocurrency for the Ethereum network that we need to pay to save particular data. And after that, there is Ethereum wallet. So it's a gateway to decentralized application on Ethereum blockchain. So it holds the ether for the apps, okay. So these are some features that are superior, and those only present in Ethereum blockchain, okay, and these things are not present in a Bitcoin blockchain. That's why Ethereum blockchain is used all over the world for the development of a blockchain related applications, right? So as we see, smart contract. So what is actually a smart contract is, and what is the property and behavior of the smart contract? So smart contract is an account controlled by a code, okay. So in the next lectures, when we see that whenever we write down some code, okay, in a Solidity, and when we deploy that code on the Ethereum network, that time we get a particular digits, okay, or address for that particular smart contract, right? So whenever we deploy our smart contract on a network, we get address back, right? So it is a account controlled by code, right? So whenever you want to interact with the smart contract that you have deployed, you need that address, okay. So that is the thing. After that, a smart contract has a properties like it can have the code, it can store your data, it can store your balances, right? So these properties are also presented or is present in a smart contracts. After that, smart contracts can be deployed on a same network with multiple instances, or you can deploy on a multiple networks also. So there are some test networks present on Ethereum, like Ringkeeper test network, Kovan, Ropsten, and Ethereum, right? On those networks you can publish your smart contracts and communicate with your code, right? After that, when smart contracts deployed on any network, then we get a particular address, as I said just earlier, right? So what are the smart contract languages other than Solidity? So as we know, the Solidity is the main language for the Ethereum based blockchain thing, right? The Solidity is a contract oriented high level language whose syntax is similar to your JavaScript, and it is specifically designed for the Ethereum virtual machine. Okay, but if you don't know about the Solidity language, and if you don't want to learn the Solidity language, then, and if you are familiar with the other languages like Serpent and Python, then also you can write the code in Python and Serpent, and you can publish your smart contracts and dApps on the Ethereum network. There is no problem, because these languages are also supported by the Solidity Ethereum network. And the upcoming smart contract languages are also coming, like Viper, Alice, and Chain. Okay, those are upcoming smart contract languages that you can use in the future to write down your smart contracts. After that, what are the Ethereum clients? So as I told earlier, that Ethereum is a network having nodes, right? And we published our smart contract on that nodes. Okay, but if you want to communicate with the Ethereum smart contract or that particular node, then you need a clients. Okay, so there are multiple clients present right now in the world through which you can communicate with your smart contracts. So the clients are like Go Ethereum, MetaMask, Mist Browser, Parity, Ethereum Plus, Ganache, and all those are the clients present through which you can communicate with your blockchain. After that, if you want to download the whole main net or the Ethereum blockchain onto your computer, you can use this Get program. Okay, that will download the whole blockchain data into your PC, and you can be a part of the Ethereum network also. So these are the some clients that you can use. Okay, so this is all for this lecture. We will see the next things in the next lecture. Thanks for watching. Hello everyone. So today we are going to look at this topic, Solidity. So this is the programming language in which we are going to develop our smart contracts for Ethereum network. So Solidity is a programming language. As we discussed in our previous lectures, that Solidity is a high level language, and it can support almost all things, functions, and it is a very expressive language. So before diving into the practicals about smart contract coding or writing the code, we are going to look at some things of Solidity. So let's get started with the Solidity. So as seen in this image, here is the structure of a Solidity program. So it is the same like any Java file structure or JavaScript class. So here is the header file. After that, here is the contract. So it is just like a class in a Java, and the functions and other things is there. So Solidity is not a very different language from you can say Java or from JavaScript. It is similar to them, but the syntax is different a little bit. So it has a similarity, like it has a same class structure like Java or JavaScript. It supports functions, it supports imports, it has a control structure like if else. Also you can use loops like a for loop or a while loop. Also it supports some data types like uint, that is unsigned integer, boolean, array, struct, mappings, addresses. So these are the similarities which you can find in Java also or in JavaScript also. But there is some differences also, just like Solidity doesn't support float values. Okay, so this is the big difference. So you can't use a float value in a Solidity. The people who are developing Solidity language are working towards it. In the future, it might be possible that you can find a support for float values, but right now it doesn't support float values. Okay, also there is a similarity that you can inherit other functions or other contracts. So this is also possible in Solidity. Also there are some special structure like some modifiers or a modifier class that you can use in this Solidity language. So if you are going to write down some function in a Java or a JavaScript, that may look like the same in Solidity. So this is the Solidity function. So how you can write this? So this is a function. Okay, you have to put some function name here. Then this is the public view. So this is a function type, and it returns a string. So this is a return type, you can say. Then you can open the parenthesis here, and this is a returning some value to the caller function. So this is the same just like you do programming in Java or in JavaScript. There is no too much differences. There are some only basic differences or some additional access modifiers present in Solidity, like pure, payable. Okay, so pure keyword no one used. I haven't seen any smart contract that is used pure keyword, but many people use this payable keyword, okay, or this public, private, view and constant keywords. So we will see what is meant by public. So everyone knows that if you define any class or a method or a function as a public, then anyone can call this function. Okay, so in Solidity you can any other smart contract, okay, that also can call the function which is publicly described. Okay, so anyone call this function. After that there is a private, so only this contract call this function. Okay, so you whenever you write a private keyword before any function or a contract, then that contract or a function becomes a private, so only that contract can access those things. After that there is a view keyword. Okay, so this returns data but doesn't modify contract data. Okay, so as you see in this function, that this function is returning some value, some view. Okay, so you can use a view or a constant, both are the same, but just there is a keyword difference. Just many people use view, or many people can use constant also, but they do the same thing. After that there is a payable keyword. So payable, we use payable whenever you want to access some ethers, or you want to get ethers to that function. So that time you use your payable keyword. Okay, so we are going to see all those things in our practical sessions where we are going to use this payable, private and public keywords. Okay, but right now we are just looking these things theoretically. Okay, then after that, how we can deploy our smart contract. So in earlier lectures, as we mentioned, that we can use different tools to deploy our smart contract on different networks, like Remix. Okay, after that test RPC, Geth, Ganache. Okay, so there are lots of different networks present. So on them we can deploy our smart contract. But how this smart contract actually compiled and runs on the network. So whenever we write down a smart contract, then that smart contract will be compiled through any tool, and then we get two files after compilation of the smart contract. First is your bytecode and second is ABI. So we get two files from our compiler, bytecode and ABI, and after that we just deploy our bytecode on our networks. We don't deploy ABI. So what is ABI? So it is application binary interface, which we are going to use, or which people use to communicate with your bytecode, which is deployed on your networks. So whenever JavaScript code or a front end wants to interact with your smart contract, then you have to use that ABI file or ABI code to access the functions or contracts that are present in a bytecode. So what is actually a ABI looks like? So this is the structure of an ABI. So here you can see the structure. It is like a JSON. It's a JSON like structure. So this is a JSON file, you can say, and it contains all the information which you can use to interact with the smart contracts. Without ABI you cannot communicate with the smart contract. So ABI is very important interface we will need in the future also to communicate with our smart contracts. So this is the ABI. After that there is one more thing about the smart contract, that whenever you deploy your smart contract on any network, then please test it before deploying on some Ethereum network or on some test network, because whenever you deploy your smart contracts on those networks, you can't change them. That's why it's not possible to change any code or redeploy at the same address. So that is not possible in Ethereum blockchain. So please test your application and do proper programming before deployment. So I will say test properly before deployment. So these are some points that you need to remember before diving into the writing of code. So these are some points, so please take care of these points. And in the next lecture now we are going to dive into our smart contract things with the remix. So thanks for watching. Hello everyone. So in the today's lecture we are going to see the remix ID and how we are going to use in the smart contract development, and how we can test and run the program on remix ID. So let's get started with the remix ID. So what is actually remix ID is it's a browser based ID in a cloud. Okay, and remix ID is used for smart contract development. It is the best tool you can have to write down your smart contracts before writing down in some other softwares, because remix has some very good features, like it has an integrated debugger, integrated testing environment, it has a static analysis, and it can also deploy your contracts on some testing networks also. And what is the good part of remix is that it also works with the MetaMask or Mist. If you don't know about the MetaMask or Mist, then don't worry about that. In the upcoming lectures I will show you what is a MetaMask or a Mist. Okay, and if you want to check out the site, you can go to this link, that is remix.ethereum.org. okay, and there you will find, so let's me go there. So here you can see so this is remix browser based ID. So here you can find different options where you can create a new project. This is the file explorer where you can open multiple files and you can work on multiple files at the same time. So this is the predefined program that comes up with the remix ID when you open this for the first time. Okay, after that there are compile, run, analysis, testing, debugger and setting tabs also here. Okay, I will show you these tabs and how to use actually this in the upcoming time. Before that we will see other features like the remix provide you the syntax highlighting also. Okay, as I just mentioned you that you can open multiple files in a remix. After that if you write a smart contract code into the remix ID, and if you have some error, it can also highlight that error and it can suggest you what to do for that error. Okay, and the best part is that it has a simulated blockchain, so you does not need to set up anything, any programs, any softwares to test out or run these programs, because it has a simulated blockchain. Like you have the JavaScript virtual machine on which you can deploy your smart contracts and test. After that you have an injected Web3 object, right? If you want to work with the MetaMask or a Mist, you can use this injected Web3 object. And third one is your HTTP RPC local get node. If you want to work with the real Ethereum node that is downloaded on your PC, that time you can use this HTTP RPC protocol. Okay, so these are some features that you can use, and the main thing that Remix provides is the step-by-step debugging features, because many of the times a developer need to debug the code while developing that or writing that code. So debugging is inbuilt feature in the Remix ID. So it highlight your step-by-step code while debugging. Okay, you can view instructions and you can monitor local variables in that debugging state, right? And it will also warn you about the unsafe code warnings, like something like that, because it has an analysis features inbuilt in that. So it shows you warning about gas costs also. Okay, after that if you using a constant variable or something like that, it also checks that whether it is properly used or not. So the state of the art analysis present in the Remix, right? So let's go to this website again, and we will write a small contract in this, and we will run this, and I will show you how to compile and run the code in a Remix. Okay, so let's get started. So I don't need this program that is predefined here, so I will just delete this code here. Okay, and I will write down a small example for you guys to understand how the Remix how the smart contracts are written. Okay, so first of all we need to declare your library or the compiled version on which you are going to compile this code. So that need to be declared in the first line. So we will declare that using this pragma solidity upper arrow 0.4.23. so I am going to use a 0.4.23 compiler version, okay, for my test program. Okay, here you can see. So this line will tells the Remix or any other Solidity compiler that we are using this version for compilation of our program, so use this version to compile our program. So after this you need to write down the contract. So as you, many of the guys is I don't know, but if you go to the internet and if you find some sample smart contract code, that time you can find that you need to write down a contract. So its structure is like JavaScript classes, or you can have Java classes like structure. Okay, so the structure it follows is the same like your JavaScript classes or like Java, right? But the keyword and some syntax is different. Okay, and Solidity is a higher level language, but it does not support all the functionality that the JavaScript has, right? It's had some limitation and it had some problems because it is an evolving language, and that's the problem with this programming language. But for a start, you can write down a better smart contracts in this also. There is no problem in that, right? So just let me start with my contract. So write down the contract, give the name like inbox. Okay, and open your parenthesis, and this is just an example that you can also type in this Remix browser on your computer and test it out that how things work in Remix. So let me define a string here. So string, I'm making it a public, and I'm making this variable as a message, and after that I need to write down a constructor. So constructor, and I am passing the string initial message public, open your parenthesis or curly braces. Okay, so I have just defined a constructor, and I am passing an argument of a string value called initial message, and I am going to set this initial message to this variable by doing this. So let's message is equal to initial message. So as you know, many of you know, the constructor will be deployed just after this contract has been deployed, and this constructor will be called just only one time when this program runs for the first time. So when this program runs, whatever may be the initial message, that message will be set in this message variable, right? So that's why we have written down this constructor. After that, as we have seen in the Solidity basics, you can define the functions. Okay, so I am writing the functions to set a message. So string new message, I am making it a public, and in the set message, I am whenever I call this function set message, I will set a message variable with this new message variable, or the value that I got from the user, right, in this argument. So just set your new message value here. After that, I am going to write down another function that will give me that whatever the message variable has stored in that, right? So let's write down this function get message, and I am not passing here anything because I am just getting the value from that message variable, right? So I just need to make it public, and whenever you return something or you just need to read the value, okay, that time what you can do is that you can use this view keyword and returns your whatever, maybe the string or uint, whatever you want. So I am returning the string here. My return type is a string type, and just return your value. So return your message here. Okay, so this is the just basic code you can write down for a practice purpose in a remix. And if you now see here that you'll find there are some warnings right here. Okay, and this is the compile tab. Here you can select the compiler version that you want. Okay, but I am sticking to the latest one here, and that is this version here. Okay, and if you want to auto compile this program, you can also auto compile this program, or you can just click on this button and start your compilation. So now here you can see my contract inbox right here is in a green color, and this shows me that my contract don't have an error. Okay, if I make some changes here, like something like this, and you can see it just gives me error because I have clicked on this auto compile, and my compiler just find out that you have an error in this particular line, right? And it is giving me some suggestions also to remove this error here, right? So this is a very fast compilation thing that Remix provides you. So just cancel this. Okay, and again it is showing you that your inbox contract is ready to deploy. Right now we have to run this smart contract. So just go to your run tab, and here you can see a different type of tabs, right? And this is the main screen where you will choose where you want to deploy your smart contract, and what are the things that you are going to do with this, right? So here you can see environment. So as I just mentioned in the slides, that you have three things that it provides you, like JavaScript virtual machine, injected Web3 when you're using MetaMask or similar provider, and Web3 provider whenever you want to work with your local host RPC, right? So just for the testing purpose, I will go with this JavaScript virtual machine. Okay, after that you will find here the accounts, and Remix provide you the 5 accounts with 100 Ether each. So these are 5 accounts, and they have the balance of 100 Ether. Yeah, because as you saw in the previous chapter, I have mentioned that whenever you have to do some operations on a blockchain, you need to pay some ether or a gas, and that's why we need some testing ethers, or we should have account with some ethers, then we can run the program. Okay, that's why they have given us these 5 accounts here, and with the 100 ether each that you can use for your testing. So this is the first account that I'm going to check it out here, and this is the gas limit. Okay, they have provided here. Okay, this is the default gas limit. You can change it if you want. Okay, but I'm leaving it as it is. Okay, and after that there is a value. Okay, if there is a function and that is a payable, right, that time you need to pay some ether to that function. That time you can use this value function value thing here, and you can pay for that particular transaction. Okay, but in this contract I have not used any payable function. That's why I'm not setting a value here. Okay, so after that, here you can see your inbox contract. So whatever may be the contracts in your program, okay, all the contract list will be shown up to you here, and you can select that particular contract, and you can just click and deploy here. Okay, so I will just go here, and it is asking me to pass initial string. So I'm going to pass an initial string like hi, okay, or hello, and I will deploy this. Okay, so here you can see that my contract is now deployed here with that particular memory address, and here you can see that my balance of first account got decreased by some ethers because it paid some ether to the for the deployment, right? So now I can go here and we will check out this. So here you can see that my contract is deployed and I have two function and one variable here. Okay, so I am seeing the variable here because whenever you defined any variable as a public, that time this variable acts like a function. So that is the thing in Solidity. So whenever you declare any variable as a public in a Solidity, that time that variable acts like a function. Okay, so if I don't click on any of these things, right, and when we have deployed this contract with this hello string, right? So if you click on this message, you will get the string hello, right? So it just returns you this particular string, whatever may be the saved in this message variable, right? Okay, and if you want to change this, you can go here and we will set the string, a new string here in a set message, like I'm going to say hi everyone. Okay, and I will click on this. Okay, and here you will find, whenever I click on this, here you will get a green sign that your things are correct. Okay, and your function is now set it properly. So this is the thing, and here you can, if you going to open this, then you will find that there are lots of things here, like gas cost and on which account it has been deployed, transaction hash and everything. Okay, and if you got any error, that time it will give you the red symbol here, and whatever may be the problem that you can have here. And if you want to deploy this thing, just click on this debug and it will take you to this debugger function where you can debug your program step by step, right? So just I have clicked on this set message, and now if I click on this get message, so this is the thing I am getting, hi everyone, because I call this function with this string and I set it up this hi everyone in this new message and I pass to this message, right? And when I get the value from this message variable in this function by using this get message, I got that string back. And if I click again on this message, I should get this hi everyone, right? So this is how the things works, right? And if you want to if you don't want this variable functions to act like a function, right, then just go and make it private, right, and then recompile your program, go and redeploy this, right, some with message like hello everyone. So just do that thing and just deploy this, and here you'll find only two functions that we have set it up. Okay, so this is how the things works in a remix. Okay, for practice you can write down this program as it is and see how actually remix works. Okay, in the upcoming lectures for our project we are going to use this remix ID very heavily, because whenever you write down a contract, first go to the remix and test it out properly, because you can test all the functions and all the things very clearly in the remix, and if everything goes clearly in the remix, and if there is no problem that you got in a remix, then you can copy those contracts and just put it in the truffle framework, and there you can run those smart contracts without any error, because you have already tested those in the remix. So that is the beauty of the remix. So in the upcoming lectures for the ERC 875, we are going to write down some smart contracts, and that all the functionality of that smart contracts we are going to test in this remix ID. So we will meet in the next lectures. Thanks for watching. Hello everyone. So in the today's lecture we are going to see difference between ERC 20, ERC 721 and ERC 875, and what is actually the difference between these three ERC protocols and at what functions they differ. So let's get started with the ERC 20 first. So you can go to the google.com and you can find lots of resources available for ERC 20 token. Alright, so if you go to the Google and type that ERC 20, there are lots of resources available on internet. Okay, and you can find it. So as of many of you know that ERC 20 is the first token standard that was published by the Ethereum, and this is a very super hit token protocol, and still people use this protocol for their token based contracts and functions. Okay, so this is a fungible token, means that in ERC 20, whenever you mint a token, so all the tokens are the same and they have the same value. Okay, so if you go to the website here and find out the functions here, and these are some functions, and this is the contract here, ERC 20 interface, and functions like total supply, balance of allowance, transfer, approve, transfer from, and these are the events. Okay, so what is the main difference between ERC 20 and then ERC 721 and ERC 875? So why they need to go for these next protocols, right? Because the ERC 20 is also a very standard interface they have provided. But the problem with the ERC 20 token is that just I mentioned that it is a fungible token, right? Means all the tokens that you are going to mint from this contract have the same value, have the same properties. Okay, so if anyone wants to different tokens with a different value, with a different properties, so that time ERC 20 has some limitations, right? You cannot create a non-fungible tokens, means you cannot create a different and unique tokens in ERC 20, and that's why developers needed to move from ERC 20 to the next protocol, and they invented this ERC 721 protocol, and that is a very huge hit again for the people who needed such a protocol, right? So if you go to the google.com again, and if you type ERC 721, and if you go to this website of ERC 721, you will find the description, and here you can see this like difference between ERC 20 and ERC 721, sorry, that a class of identical tokens are generated in ERC 20 and a class of unique tokens are generated in ERC 721, as you can see from these images also. So in ERC 20 you will get same images or identical tokens. Okay, there is no difference, but in ERC 721 you will get every time a new token. Those and not two tokens are not same at any point. Okay, So here you can see the image, and this is the interface for ERC 721. Okay, this has the same functionality as of ERC 20. Okay, but just there are some little bit of difference regarding the token IDs and some parameters they have passed into this interface. So that is just a difference. Okay, and on this ERC 721 many games have been developed, like crypto celebrities, crypto kitties, and ether tulips, right? And those are very hit games, and people have gathered some amount of money from these games, and these games are possible because of only because of this ERC 721 protocol, because it provides very unique things, right? Like if you go to the cryptokitties.com, cryptokitties.com, and there you will find this all game is based on this ERC 721 protocols. And what is this game is all about? Here you can have to breed very different and unique adorable kittens here, and those are unique. And after that, after you breed those kittens, you can bless them for the sale, and people purchase those kitties for very large amount, right? And that's why it is very hit game on the internet right now. Okay, but we are interested in this course regarding ERC 875. So what is the difference between then ERC 721 and ERC 875, right? So actually there is not too much amount of difference between ERC 721 and ERC 875, right? Because ERC is an also standard non-fungible tokens, and ERC 721 is also a non-fungible token, right? Means that ERC 721 and ERC 875, these both the tokens actually produce a non-fungible tokens, means their output will be the same. You will get every time the unique token. Okay, right? So why there is a need to produce this ERC 875 protocol for these tokens, right? So actually the problem with the ERC 721 is that whenever you want to sell some tokens, that time the seller also need to pay the gas, and buyer also need to pay the gas for the transactions, right? And that is a very huge problem for the Ethereum network, because they clog the network because of this gas fees, and you can't sell batches of tokens at one point in ERC 721, and those problems are actually eradicated and removed in the ERC 875, and other functionalities are the same. Okay, if you go to google.com and you will find, if you find ERC 875, and you to go, if you go to some of the pages like their GitHub pages, okay, here you find that ERC 875 is a non-fungible tokens with the simple atomic swaps. Okay, so what is that? Okay, so if you go to the functions here, so the same functions actually you will find in ERC 20, ERC 721 and ERC 875. So same functions are also here, like name, symbol, balance of, transfer, transfer from, total supply, owners of, right? All these functions are also present in your ERC 721, right? But there is a difference of this atomic swap, and you can call it as a trade function. So this is the difference between ERC 21 and 721, sorry, and ERC 875. Okay, so this new trade function is they injected in this protocol, right? So this is the new function in the 875, and this is a very beneficial function because as you can see in this documentation, this function actually a function which allows a user to sell a batch of non-fungible tokens without paying for the gas fee. Only buyer has to pay the gas, okay, in a P2P atomic swaps, right? And this is achieved by signing an attestation containing the amount of tokens to sell, the contract address and expiry timestamp, the price prefix containing the ERCs, spec name and chain ID. So this is the only difference between your trade function in ERC 875. Okay, in this ERC 875, the seller does not need to pay the gas. Only buyer need to pay the gas for the transfer, right? And in the trade function, you can sell a batch of non-fungible tokens at the same point. Like if you have 10 unique non-fungible tokens in your account and that you want to sell those 10 non-fungible tokens in a one shot, then just you need to give those things on the ICOs or something like exchanges, okay, and you does not need to pay anything, okay. The buyer will pay the gas fees for those tokens, and he can also buy 10 tokens at the same point with the same amount of gas, okay. That is the beauty of this trade function that they have produced in this ERC 875 thing, okay. But all other functions and all other things are the same, right? For more details you can Google this, okay. There are not too much of documentation available right now on the internet on this ERC 875 because it's a very latest ERC protocol they have just produced, right? So that's why on internet there are not too much amount of documentation you will find, okay. But in the future you will find many examples and things on the internet, right? So there are some GitHub pages for its 875 protocol that you can read, like this one. There are some issues pages also where you can find many things they have discussed about this and what is the difference between these protocols, here someone asked this question, right? So you can search more on this on the internet, right? And in this course we are going to see all this functionality using the remix, okay. Like trade function, we are going to test this trade function using the remix IDE, because on remix it will be easier for us to show you the how we are going to use this trade function to sell these things, right? So all these functions we are going to test in our remix IDE, okay. Also, if you want to know more about the other functions like this balance of and transfer from, you can go to this ERC 20 token standard, because these things are same here, right? So for example, if you want to check the balance of a function, okay. So here they have given example, like there are two accounts. This is the first account and this is the second account. With the first account have the balance of 100 units and second has the balance of 200 units, right? Okay. And if you use this function like of this balance of function, here it will return the balance of a particular token owner, okay. So you need to pass the token owner's address here. So as you can see here that they have passed this owner's address to this function, and it will return you the amount of token or the units that account has, right? After that there is a transfer token balance also. So in that, if one account want to send or transfer some token to another account, that time you can use it, use this transfer function, right? Here they have given example, right? For like this. Okay, so if you go to this transfer function, you have to pass the address of the uh, buyer and the number of tokens you want to pass or transfer, right? So here is the thing. And for example, the account 1 wants to transfer 10 tokens to account 2. That time they will execute this function like this: transfer and account of the second address and the amount of tokens that you want to transfer, right? And after that, if you call this balance function again, that time it will return you the 90 and 210 tokens for that accounts, right? So here are some examples, and these are the same things that you will find, like balance of function, right? You need to pass the owner's address here, and this is the same transfer function that is also present in ERC 20, right? Because we are in route right now in ERC 875, and here you will find it is the same like ERC 721 and ERC 20. Okay, just difference is only that here you are passing the array, right? Here you are only passing the one address, right, and one amount here. Okay, but here you are passing the array of tokens, means a set of tokens you can transfer at a one point. So it is also taking two parameters here. So all these functions are same, just as I mentioned, only this function is different from other two protocols. So in the next lecture we are going to see about all these functions in a remix and all those stuff. Okay, so we will meet in the next lecture. Thanks for watching. Hello everyone. So today we are going to look at some theoretical lecture about what are the types of variable that can be supported by the Solidity, because we need to understand this variable section and the coding structures that has been supported by this Solidity language. So before deep dive into this lecture, I'm going to install a visual code into my system, and that software we are going to use for our development purpose. So let's get started and find the visual code. You can go to this Visual Studio Code website here. So website is open. Here you will find a button, download for Windows. So whatever may be your operating system, go and download this stable version. So my operating system is a Windows x64 based. So I'm going to install this software into my system. So go and install this stable version. So first let me download this. So now it is downloading here. Okay, so it is now downloaded on my desktop. So go to desktop and do the setup of this visual code. So now it is doing its setup. So just wait for a while. Just click on this launch visual code and finish it. So it is a free software that you can use as your editor to code the Solidity programs and smart contracts. So now it is opening here. It will just take some time for the first time. Okay, so actually this Visual Studio Code actually made for the Microsoft C hash codes and something like that, but it can support the languages like here you can see a JavaScript, TypeScript, Python, PHP, Azure, Docker and more. So for those language highlighting, you can use their extensions. So now we are going to use this Solidity language in this Visual Code, so we can go and install their extension from their store. So you can find the store extensions, so click on this extensions here, and here we'll find the top extensions that you can install into this Visual Studio Code editor. Okay, so like Python, C++, and other languages, but we are interested in Solidity, so find the extension for Solidity. So here is the first Solidity version that you can install. Just click on this install button. Now here you can see it is showing me that it is installing into my Visual Studio Code editor. So actually if you even doesn't install this extension into your this Visual Studio Code, then there is no problem actually. But why I am actually installing this software, because it highlights the syntax, the correct syntax for the Solidity. Just like here you can see that the syntax highlighting, snippets, okay, compilation of the current contract. So this can be possible with this Solidity extension here. So this will help you to understand the highlighting of the Solidity program, their contracts and other things. So if you wish to install this, you can go and install this extension into your Visual Studio Code, or you can use any other editor for this. It sometimes takes some time because it's a little bit huge extension. That is why it is taking some time, I think so. Okay, but it is taking okay. So now it is done with the extension. So just close this. Okay. So as we discussed earlier in this thing, that we are going to look at the types of variables supported by this Solidity language. So what we can do is that we can go to the file, new file. This I am typing that I am not writing down any Solidity code here. Okay, I am just showing you what are the types supported by the Solidity language. So the strings, as you know, the variable type supported by Solidity. Let me zoom this. So first is a string. Everyone knows that string, like hi, hello. So these are the string which is supported by Java and other programming languages. So Solidity also supports a string type of variables. And after that, it also supports a Boolean like true and false values. After that, it also supports integer, like as we know, 0, minus 100 and 100 and plus value like 100. It has a new you can say variable that is very important and that is widely used in Solidity, that is called unsigned integer, that is uint. This is unsigned integer, so it has only positive values, it supports only positive values, means that you have only 0 and 100, but you cannot have minus 100 here values, only positive value it supports, positive values it supports. Okay, so after that float is not supported by the Solidity. Okay, and there is also a new variable called address, so which gives you the address of the owners and senders and everything in the format like 0x8465367 something like this. Okay, so these are the some variable types that it's supported by the Solidity language. Okay, so if we go into the deep about this like integer and uint, their ranges, so let me give you some details about those. Okay, so what is the main difference between this integer and uinteger range? So many of the people you know that integer starts with integer value like 8, after that integer 16 is there, after that integer 32 is there, and so on, and last value is the integer 256. Okay, and as you know, integer 8 only supports up to minus 128 to upper value is 127, and integer 16 supports from minus 32,768 to upper value plus 32,768. Okay, so just like that the number goes on increasing at both the end, at the negative end also and at the positive end also. Okay, like in 256, integer 256 supports really big number, big negative number, you can say negative number, and at a plus side, upper side, it is a really big positive number. So this is the main difference between the integer 8 and integer 256, that it their range is different. Okay, so actually many of you use only integer, you never use like integer 8 and integer 256. So integer is as same like integer 256, both are the same. So in many examples in Solidity also you can find integer or integer 256. Okay, so both are the same, there is no difference between this. Okay, but as we discussed that there is a uint, that is unsigned integer. Okay, that is also supported by the Solidity. So it has also, it starts with uint 8, its lower value is 0 always, and upper value is 255, and uint 16, its lower value is also 0 and upper value is 65,535. Okay, and just like the same way in integer, it supports uint 256 and its initial value is also 0, but positive value is really big positive number. So uint only supports a positive number, it doesn't support any negative number. So in Solidity many of the people uses this uint 256. So in our program also we are going to use this uint 256, or you can use uint sorry, I have some spelling mistake here. So uint, and so uint, and that is same as uint 256. So it is also the same, that is u integer is equal to u integer 256. So you can use any of these things. Okay, so as we have seen that in this lecture that it supports many different types of variable like string, boolean, integer, uint, and addresses. Okay, and we have gone some in details for the integer and what is the uint. Okay, so it is just a variable supporting video, actually what the variable it supports. So in the next lecture we are going to see another things that it's supported by the Solidity, like mappings and struct, and what is the message variable. Okay, so that we are going to see in the next lecture. Thanks for watching. Hello everyone. So today we are continuing our last lecture. In last lecture we have seen that what are the variable types supported by Solidity. So in this section I am going to show you what are the structures and what are the new types of things that it's supported by this Solidity. So first I will show you the message variable. Okay, so you can say it is a global variable. So what is a message variable in a Solidity is that it has the address of the contract. Okay, you can have this message variable accessible wherever you wanted in the code. So this is a global variable by default, so you can call this message variable in any function or in any constructor. Okay, so this gives you the address of the owner who is either sending the money or sending the ether, or the address of the contract. So you will see this message variable many of the times in Solidity language. So always remember that this variable is a global variable and that can be accessed anywhere in the program. So this is the by default variable that has been given by the Solidity to us that we can use in our programs. So another things that Solidity gave us is a mapping. So mapping is a collection of key value pairs. It is just a collection of key value pairs. Okay, all the keys in a mappings must have of the same type. Okay, just like for example mapping. So this is the syntax for mapping: string, okay, or mapping integer and boolean. So it is a collection of key value pairs. Okay, many of people know that this is also used in other languages, but their name is or syntax is different. Okay, so in Java, like you can say it is a hash. Okay, in Python you can call it as a dictionaries. Okay, something like that. Okay, but in Solidity we are going to call it as a mapping. Okay, so it is a collection of key value pairs, and as I said, all keys must be of the same time and all values must be of the same time. Okay, so this is the mapping. And if you want to use a collection of a key value pairs that has a different types of values or keys, then you can go for the struct. Okay, so it is a collection of key value pairs that can have different types. Okay, for example, let me give you an example. Okay, first write down it's also a collection of key value pair but of different types. So for example, you can have a struct car, and in that you can have the string make string model and event value. So as you can see here that it is a structure of a different key value pairs. So here you can use a string, okay, and you can also use event or boolean or any other variable type. Okay, so it will give you the different types of structure that you can use as a variable in your program. So this is another things that is given by this Solidity. So in our program also we are going to use this struct thing and the mappings thing and message also. So this is it for this lecture. So we are going to see the program in the next lecture. Thanks for watching.
Hello everyone. So in the today's lecture we are going to install the essential softwares for our smart contract development and for our project. Okay, first of all we need to install the Node.js. Okay, so you can go to the google.com and find Node.js in that google.com. Go to this website, that is nodejs.org, and here you will find different version for different operating systems. Okay, but I have a Windows 10 operating system which is a 64-bit, and for that I am not going to go with the current version, that is because it's a current and unstable version right now. So they have recommended 8.12.0 version, that is the latest one, and this is the stable version that you can download for your software. Okay, so just click on this and it will get downloaded here, and after that click on this and do the setup. Okay, so it is now doing the setup here. It will take some time depending on your PC's hardware configuration. Okay, so it is, yeah. So wait for some time to complete this setup. Okay, and after the setup has been done, okay, just click on this finish, and you can now then go to your command prompt and open that command prompt in administrator mode. just like this, run as administrator. And you can check the node version by using this command, that is node minus or -v. Okay, so this is the version that I have installed here. After that, I need to install truffle also. Okay, so for truffle, what you can do is that you can write down this command in your command prompt, that is npm. Okay, this is a node package manager which help you to install the other softwares. So npm install -g truffle. So it will get downloaded and will be installed on your system. And you can also check the truffle version using truffle version command. Okay, here you will find that you have this truffle version of 4.1.14 and the solidity version of 0.4.24. okay, that is the latest one on the solidity. Okay, so now we have installed the node JS library and this truffle software. Now we need to install the Ganache. Okay, that is our test network for offline testing, and for that we need to go to the truffle website. So just go to the google.com again and find truffle framework, and this is the website. Just click on that and go here, and here you will find a Ganache. So just click on this GitHub repo here. So there are two versions. One is a command line version and second is the desktop version that has an UI. Okay, so this is the UI version, and another is the CLI version. Okay, you can go here and click on this Ganache. Okay, and okay, so now just go here and click here, that is need another OS download, and here you will find this version here, different versions, but I am going to go with this version, that is the exe file for Windows. So now it will get downloaded here. So wait for some seconds to download it. Okay, and click on this to do the setup here. And just install this. And click on this finish button. So now my Ganache will run automatically after this. So now here it is open. So just disable this analytics enable. So disable this and click on this continue, and this is the graphical version of the ganache. And here you will find some accounts with the balance of ether. Okay, there are blocks, transaction here you can see. So this is the just test local test network which we will use for our testing of the smart contracts. Okay, so you can go and download all these softwares from the net as per this video and install it before we can start with the smart contracts coding. So we will meet in the next lecture. Thanks for watching.
Hi everyone. So today we are going to look at our project. So we are starting with our project. So we have to write down some smart contracts in a truffle. So in last lecture we have installed a truffle. So now we have to start with our project directory, and we are going to check how to create the files for our smart contracts and how to use truffle. So let's get started with command prompt. So I am opening a command prompt here. Okay, so now what we have to do is that we have to make one directory there. So go to your particular drive, cd any drive. Okay, I am going to the core of my drive by using cd dot dot. Now I am going to make a directory here. Token. So here you will find a token directory is now been created. Now I have to go to this directory by using this command cd token, and now I am in the token folder. Here I have to initialize my truffle project here. So the command for initialization of the truffle is like this: truffle init. So just run this command. So whenever you run this command, it download and unpacks some folders. Okay, so it will give you the project structure, project files that you can use for your project. So now we are going to open those files, but for those files you need some editor to open those files and to write the code in those files. So now we will go to some editor. I am going to use a visual code in this project. So go to google.com and find visual code. You can use any other editors also, but I prefer this because it's an easy. So you go to this link and you can download this stable version. Okay, my PC is Windows 64, that's why I am using this. Okay, so I am already downloaded and installed this visual code in my PC. So I'm not going to again install this software. So now just I'm going to open this software and I will show you the folder structure. Okay, so now I open this Visual Studio Code software. So this is the interface for this. Okay, so now what I have to do is that I have to open this folder that we have just created in a C drive. Okay, this is a token folder that we have created using the command prompt here. Okay, so just open this, select a folder, and here you will find that your project is opened here. So there are some folders which was created in the command prompt automatically by using this command, so you does not need to make this folder manually. So we are going to look at these folders, like what is the contracts, migrations and test. Okay, so this contract folder is where we are going to keep our Solidity files or write down our smart contract codes. So this folder we are going to use for our smart contracts. Okay, after that there is a migration folder which is used to deploy our smart contract script that can be used to deploy our smart contracts on particular networks. Okay, after that there is a test folder that can be used to test out our smart contract code. In this folder we have to make some test files and run that test files to check whether our contracts are okay or not. After that there is a truffle config file and there is a truffle.js file. So this file contains the network code on which you want to deploy your smart contract. If you want to read more information about the structures and files, then you can go to the Truffle website. So that is a Truffle framework here, and you can go to the docs, and in that to just click on this Truffle, and here you will find creating a project with the Truffle. So as I just mentioned the steps in this video, those steps you will find here also. So just like make some directory, then go to that directory and use this command, truffle init command. Okay, so I have used this command, and there are some more documents or information you can get from here. So like Solidity contracts, script table deployment files, and configuration of files. So all the documentation is available on this website, so you can go to this website anytime and you can read in more details on this website. So on the next lecture we are going to write down our smart contracts in the Truffle, and we are going to test and deploy them in the upcoming lectures. So we will meet in the next lecture. Thanks for watching.
Hello everyone. So in today's lecture we are going to write down some code for ERC 875 smart contract. Okay, for that we can go to google.com and we will find ERC 875. Okay, we will go to its GitHub pages, and here you will find the specifications for the ERC 875 non-fungible token. So this is the interface that we are going to write down in our code. Okay, so for that I will use Visual Studio Code, right? So I'm not making any changes to my previously created project, that is our Truffle files. Okay, I am just going to write down code in a single file, and we will take up that code and we are going to take that code to the Remix ID browser based ID, and there we will put that code, and we are going to test everything that is specified here. All those functions we are going to run on Remix. Okay, because it's easy for us to run every specification or every function on Remix rather than on Truffle.
right? Because if you want to test everything, those are mentioned functions in this contract, then you need to write down a very large or big program for this, and for that it's easy way to you can have that is that you can write some small amount of code, okay, some functions, and you can take up that code and put that code onto the remix and you can test. Okay, so first of all we need to write down the code for that. Okay, so first of all I will create a file here, so just make a new file here and save it here. So I'm making its name erc.sol. Okay, so I have now created the file erc.sol, that is a solidity file, and after that I can write the code in that. So contract ERC. Okay, and in that contract you can write the code that is mentioned here, or you can just copy and paste this code. Okay, so I am going to copy this code from the GitHub pages. Okay, all the functions that are defined here. So this is the standard functions that these protocol supports. So you does not remember, it doesn't need to remember anything. You just need to copy and paste this code here, and these are the optional functions. Okay, so in this tutorial we are not making any ICO or something like that, so we don't need this total supply functions, so that I'm not going to use for this program. And after that you can have your owners of function and the trade function. So the important function that we are going to test for this ERC 875, and that is the trade function. It is the different function from your ERC 20 and ERC 721, right? And this is the main function that is introduced in this ERC 875 protocol. Okay, so I'm going to use this trade function and just copy and paste it here. Okay, and we also need the events for transfer. Okay, but that is not mentioned here, so let's find out that event also. So go to the google.com and find the GitHub pages. There also you will find. Okay, so these are the event also, so you can go here, and we need this event, and I will declare on the first of line this. Okay, so only these functions we are going to test, and the main function that we already write down here, right? That is your trade function. That is the main function that we are going to test in this, right? And okay, so now we have done with our ERC contract interface right here. After that, what I need to do is that I need to write down a code that will interact with this contract. Okay, so what you can do is that you can make another file, and that in that file you can write down that code. But for example purpose, I'm just going to write down that code in this same file. Okay, so you can have this pragma solidity compiler version DT 0.4.23. we are using the latest version, that is a 23 for our project. And you can write down your contract, give it the name of the contract, and A is ERC. So we are referring this ERC here, right? Okay, and in this now I am going to write down some code that we need to test all these functions here. Okay, and for that I need to, first of all I need to declare some variables for this. Okay, so just I'm going to declare some functions, and I'm writing down the code for that. So unit address and it is an array of inventory, and now we need to uint 16, or you can use 256. Okay, ticket index. Okay, so to track the mapping in tickets, I am declaring this uint here. So here is spelling mistake. Okay, you can have to track mapping in tickets. Okay, so you will get understanding of this. And after that, uint expiry stamp. Okay, so all these variables that we are need, because of they are already present in their interface, like this timestamp, owner, okay, value of admin, total indices and everything. That's why I need to declare, and I need to use those things here also. Okay, and I need the owner address of the owner. Okay, so this will the address that calls self destruct and takes fees. And I also need the address of admin. I need also uint transfer fees to check out this trade function or transfer function. After that, uint transfer, and I am initializing its value to 0. After that I need two strings here. First is your string public name and string public symbol, okay, for your token, and name for your token that we are going to use, okay, that we are going to store in these string variables. And after that, event 8 public constant so these are the some variables that I have mentioned here. Okay, in the next lecture we will continue with this code. Okay, so these are the just variable that I have declared. After that I need to write down some more code. Okay, so we will meet in the next lecture and we will continue with this. Thanks for watching.
Hello everyone. So we are continuing our last lecture, that is we are writing down code for our smart contract to test out this interface function. Okay, so if you want to write down this code, you can write down this code, or you will find the GitHub pages for this code also. Okay, so if you go to this link on GitHub, you will find this code also, because it is produced by the owners of ERC 875, and those are the contributors. They have published this code on their GitHub pages also, or you will find the links on the internet also. So you can go to this ERC token implementation.sol, and from here also you can copy this code. Okay, so in the last lecture we have actually written down this amount of code. Okay, and in this lecture I am going to just copy this code. Okay, so let's copy this code from here and we will paste it here. So there is also an explanation for this they have given here, right? Okay, so for example they have declared the modifier here. Okay, so they are checking the message.senders address that should not be equal to your admin address. If that admin address is same, okay, then that will give you an error, or it will revert, right? So after that they made a function that is a public revert, right? And they don't want to send any ether directly, so for that they done this function here. Okay, and the main function that we are interested in this token function. Okay, because in this token function we are actually saving the array of the number of tokens. Okay, for example this is the number of arrays that you can save here. Okay, and after that the string name, expiry, event symbol and admin address, all these things are declared in this token function. Okay, and those things are assigned particular to each and every variable, right? Like just like expiry timestamp and expiry, that is it will get from this arguments, right? Then owner's address and all these things we will pass from our input text boxes, and those will be passed here, right? and after that here we'll find the trade function. Okay, and in this trade function they are taking and passing this value. We need to pass the expiry of the tokens, the token indices, how many tokens we need to trade. Okay, and after that this is the V, R, and this is the S. Okay, so if you go to the Google and if you go to their GitHub pages, here we'll find that VRS actually is the cryptographic sign or digital cryptographic sign that is used in this ERC 875. Okay, here they have explanation given. So no one can fool the system, or no one can trade the older orders. To check those things, they have produced this value of VRS. Okay, those are cryptographic sign. Okay, and for that we have a code that we can go there, and we will also able to generate that cryptographic sign. Okay, so here they have checked all these things, and after that they have trade function will run, right? And after that the encoding of the message and other things for this program they have written down it up here. Okay, so what we can do is that we can copy this thing from here, and we can go to the remix. Okay, just I need to go to this remix ID, and in this file I need to paste these things here. Okay, so now I have pasted all the code here. So in the next lecture we are going to test these functions properly with the remix, and then how we will check out that how we are going to implement the things, and how we are going to test this smart contract properly. So we will meet in the next lecture. Thanks for watching.
Hello everyone. So in the last lecture we have copied and pasted this ERC 875 contract in our remix browser. So in the today's lecture we are going to continue with that same smart contract, and we are going to test all the functionality that is provided by this smart contract on the remix ID. So let's get started with it. So now we have copied and pasted our code here. Now I need to compile this code before deployment. So this is the compiler where you can select your different compiler versions according to whatever maybe your compiler that you are using. Okay, so I am going to use the latest one, whatever may be the compiler given by the remix ID. So I am selecting the newer and the latest version, and after that I am going to click on this button that it just start to compile, and there are some warnings, okay, but no errors are there. Okay, so this is my first contract and this is the token contract. Okay, now I will go into the run tab and we will deploy this. Okay, so let me adjust this so you can see clearly, and let me do this. Okay, so now I need to run this code. So this is the token contract, because this is just an interface, that's why I'm not going to deploy this. Okay, because I'm using this interface in this token contract. So my main contract is the token. Okay, so for that choose the environment JavaScript virtual machine, your account or whatever, maybe your first account, gas limit, everything. Okay, and whenever you choose this token, and there you'll find some parameters that you will need to pass to run this smart contract. Okay, so for this you need some things. Okay, so I'm going to copy the example here. So this is the input that I'm going to paste here. So just copy here from here and paste. So these are the number of tokens that I am passing. I am passing the 15 tokens in an array. After that, it is asking me the event symbol, sorry, event name. So this is just an example. What you can put whatever you want to put in here. So just put here. After that, there is an expiry time, that is, this is in milliseconds. So just put that there. And after that, event symbol, and then there is an address. Okay, but we need our address. So our address is different. Okay, this is just example address, but this is our address actual. So you can copy it from here. So just copy and paste it here. Okay, and let me adjust this also, so you can see clearly what is happening with the transaction. So then click on this transact button, and here you will find our transaction is get successful, and our contract has been deployed on this address, right? Here you will see the green sign. Okay, and for the details you can open up this tab here, and there you will find all the things that has been decoded as input. Okay, so now I can expand this, because now my token contract is been deployed. Here you will find different functions that we have written in this, and that are present in this smart contract. Okay, so some of the functions we can check now. So just like what is the symbol, so this is the symbol that we have passed, right? MJC. After that, our symbol name, you can click on this button and you will get MJ come back, right? After that, you can check your balance also. So this is your balance, right? We have transferred 15 tokens. Is our contract expired? We should get a false result, because our contract is not expired. Yeah, it is giving me a boolean expression that is a false. Okay, after that, get decimals is of no use maximum, but we can click on that, because here we didn't give any decimals tokens, that's why it is giving me a 0. After that, get a contract address. So you will get this address on which we have deployed, right? 0x692, 0x692. After that, get amount transferred. So we need to do some operations for this. Okay, symbols. Okay, so I can also check the balance of a particular address if I want. Okay, so for that, this is my contract address and this is the owner, right? If I need to check the balance of this particular owner, then I just need to copy and paste their addresses here, and I can check their balances, right? So it has from 1 to 15 tokens, right? And after that, what we can do is that we can transfer some tokens to the other address. Okay, so here are some addresses. So this is my first address, and this is my second, third, fourth, fifth, right? So now what I'm going to do is that I will transfer some token from my first address to say this second address. Okay, So I need to go to this transfer tab. Okay, here you can see a to and token indices function. Okay, to is the address of the buyer. Okay, means the second address. So you can copy, this is the second address, just copy the value from here and paste it here. And the token indices, so if I want to give 10 and 11 two tokens to this particular address, if I want to transfer this, okay, and choose your owner's address, because owner can only do the transactions. Okay, so choose your owner's address and do the transact. Okay, so our operation is successful and we have successfully transferred this tokens to this address. If we need to check the address for this, so we should get 2 tokens for this address. Okay, just put that address here in balance of, that is 160C. Okay, here you can see the address 160C, and you can click balance of, and here you'll see 11 and 12 because it's an token indices. So this is the address, not the token actual. So address 10 and 11 has the value of 11 and 12. Okay, that's why it is showing me and 11 and 12 value. Okay, this is just address that I have passed here, and this is the value for this 11 and 12. Means at a 10th position you have an 11th value, and 11th position you have 12th value, right? So these tokens have been successfully transferred here. Okay, after that you can also check this transfer from here. You need some addresses. Okay, so the first address is from address, second is your the address to which it need to be transferred, and third is your token indices, right? So let's go and do this operation also. So I am going to copy this address, so I will paste this. Now I will choose the third address here, okay, to which I want to send the tokens, and here I will send 8 and 9 number indices. Okay, and do the transact. Okay, so it has given me an error, some error. So okay, so what is the problem is that I haven't chosen this address of the owner, because I am transferring from this address, and this is the contract address. So please, whenever you check with this such a smart contracts, always choose the deployed address or the owner's address. Okay, right? Because if you don't choose, you will get such an error here. So now again I will do the click on this transact button. Okay, so now you can see our operation is successful, right? Succeeded, you can see. And now you can check the balance for this third address from here. Just copy and paste that address and check that, right, you get the 2 tokens from here, right? So this is how you can check the all the functions for this smart contract. Okay, so another thing that we need to check is the main function, that is a trade function. Okay, and for this function is very actually tedious function, because it needs to be a cryptographically encrypted function, it needs to be a cryptographically signed function. That's why we need to generate these 2 values, 3 values, V, R, S, right? So for that we need to use some program to generate that cryptographically signed things, and then we will put that things here. Okay, so now another thing that you can use, that if you deploy the smart contracts on a Rinky, okay, so you can also test this function very easily, because on a local test network it will give you some problems. So for that, what you can do is that you can put this smart contracts on a Rinky, okay, and you can check this trade function very easily. Okay, for now, I will show you if someone has deployed any smart contracts on a Rinky, and then how you can use their addresses to fetch that smart contracts into the remix, right? So for that, what you need to do is that, okay, I need to go to this GitHub pages. Okay, so this GitHub page, and here you will find, so test out here, they have already given you this Rinky address on which they have deployed this smart contract. So we does not need to deploy the smart contracts on a Rinky. So what we can do is that we can use this address for our deployment and other things. Okay, so just copy this address from here, copy, go to your remix browser. Okay, just wrap up these things. So this is my first contract. Now what I am going to do is that I will deploy this token, okay, and fetch this token from particular address. Okay, so remix will give you this functionality that you can pull up some contract from any address. So this is the address field where you have to put that address that you have just copied or you get from the Rinky. So just put that things here and click at address. So here you'll find that my address is now been fetched from 0005, and if you go to this pages, this is the address, that is 0005. So we have successfully fetched this thing from the Rinky. And now what you can do is that you can test all these functions as we have already tested before, right? So but we have already tested the get symbol and balance and everything, okay, in this local address, but for now we have to test this trade function. So for that, what you need is to provide all these value, and you need to generate all these value from some Java file or some code. Okay, so on these GitHub pages already they have given the code for that. Okay, so if you go to this example and just click on that, and this is the code in Java, okay, on which they have they are generating the value of things. Okay, so some things are fixed, but some things are like these three things they are generating here from here, but some things are fixed, like token indices are fixed, expiry is fixed, just like that. Okay, so what you can do is that you can copy this code, or I already have copied that code. So let me open that in my notepad. Just go to the Java compiler, online Java compiler. So I'm going to this Java compiler. This is the online compiler that you can use. You does not need to install any program to generate this program's output, this Java program's output. So now I have copied my Java code from my file. Okay, so the same code you can find it here. So you also can copy this code from here and put it there. Okay, just change the address here because it's local address, and I need to give this 005 address here. So this is the just address, and this needs an external library, because if you are going to run this code without this any external library, then you will get an errors for this Web3.js crypto libraries, because these are external libraries they have used here. Okay, so what I'm going to do is that I will go here and I will add my external library. So you can also copy these three things from here. So your group ID is org.web3j. After that, second is the crypto, your artifact ID. So you will find this library online also. I have already just copied the things from that library to my notepad and just click on add. Okay, now my go and check that your external, right, my external library is now added. Okay, and then just I need to click on this execute button. So just click on this execute button. Okay, so here you will get the cryptographically signed VRS values. Okay, that you can copy and put it in the trade function, because if you go to this trade function, you need all those value, and then your operation will be successful, or else you will get an error, because it should match up with this output, whatever maybe the values that you get here. Okay, just like 1 0. So I'm going to put those value. My expiry is what? My expiry is 0. My expiry is 0. So my index is 3 and 4. So token indices you have to put in array. So 3, 4. After that you need to v value, that is a 28. So 28. So copy the value of R, put it here in the R section, and copy the value of S and put it here, S. Okay, and now we will do the transact. So just click on this transact function, right? Okay, you get a succeeded here. You will get a message that your operation has been successfully mined and execution is succeeded. So because in a trade function, the function checked that these expiry tokens and VRS values should be the same that which we have generated here. Okay, then we can trade the function, trade the tokens, or else we cannot trade the tokens. Okay, so this is the main trade function that we have seen. Okay, and these are the main values like VRS and expiry time. Okay, for example, we have expiry time, we have set it for 0, but for the real project you need to set some expiry time, and you need to generate this VRS value for that particular real-time project, and that's how you can secure your trade function with this. Okay, so this is all for now in this lecture. That we have what we have seen in this is that we have implemented all these things in the smart contracts. Okay, and we have run and compiled all these functions. We have checked all these things. Okay, like transfer from, balance of, trade function, and everything we have seen in this lecture. and we have also checked that how you can fetch a smart contract from the particular deployed address. Okay, so all these things we have seen in this lecture. So this is it for this lecture. In the next lecture, what we are going to see is that we are going to implement some interface functions, okay, some 1 or 2 3 functions from this smart contract or this interface, and then we are going to mint a token that is a unique token. Okay, in that smart contract we are not going to trade and transfer all those things. We are not implementing those things, but we are going to see that how we can generate a unique token. Okay, because ERC 875 gives us a non-fungible token. Okay, and in this lecture already we have seen all this functionality. So again in the next section I am not going to show everything. So we will just mint the tokens on the front end. So in the next lecture we are going to write down some smart contracts, and we are going to write down some front end scripts and UI, and there we are going to mint non-fungible tokens. So we will meet in the next lecture. Thanks for watching. Hello everyone. So today we are going to start with our project. So in this project we are going to mint the unique tokens, non-fungible tokens, and for that we need to write down the smart contracts for that. Okay, we have already generated a truffle structure using truffle init command, right? So the same structure that we are going to use for this project, and at the end we are going to build a front end using React.js for this project, and then there we will have the mint button, and on clicking of that mint button you will find there is a generation of different non-fungible tokens. Okay, so let's get started with the Visual Studio Code. So and open the truffle folder that you have created using truffle init command. So just click on open folder. This is my folder, so just click here. Okay, so here you will find this is my folder, which is having all the structure of truffle, like contracts folder, migrations folder, test, and truffle.js and other things, right? In the contract, migration.solidity file is already present. Okay, this is the pre-generated file that we get when we generate a truffle folder structure using the command. This is the deployment script for this migration file, and this is the test folder, right? So what we need to do in this lecture is that we need to create a smart contracts. Okay, those will generate the non-fungible tokens on the front end. Okay, and for that I need to create some files. So first of all I need to create some dependent file that I need for my smart contracts. Okay, so those are predefined files that you will get the code from the internet. Okay, so first of all just create the blank file here. So create a new file and give the name safemath.sol solidity file. Okay, and if you go to the internet and find safe math solidity file GitHub, okay, you will find the Open Zeppelin links here. So just click on that links, go to the Open Zeppelin folder structure, and this is the predefined file. Okay, this actually helps us to do some mathematical operations. Okay, so this is just an another file which you can import in your smart contracts, another smart contracts, and you can use the functionality of this safe math functions. Okay, so if you going to go to this file, and just we will copy this first from here, go to your code and paste it here. Okay, here you will find that. Okay, so this has the all the mathematical functions like multiplications, division, subtraction, addition, and other functions, right? Reminder and all those things. Okay, so whenever you have to do some mathematical operations in your smart contracts, that time you just need to import this file, or you can just copy and paste this file from the internet, and you can use this file references into your smart contracts. Okay, so I am getting an error of this file because of this my Visual Studio Code. Okay, so I am going to change this CRLF to LF, sorry, and okay, so my errors are gone. So this is the problem of my editor, not the with the code. Okay, so you just go and change this if you are using this Visual Studio Code, and save this file. Okay, another thing that we need is the owners file. Okay, so that owners file also give you the authorization, okay, owner's address, and it provides the authorization control functions. Okay, so that simplifies your implementation of the user's permission. Okay, so that is the file that you also get from this Open Zeppelin smart contract folder. So you can also go to the, before that sorry, I just need to create the file here, that is ownable. Now so go to the google.com again, and this time check for the ownable, and here you will find the ownable file. So this file you can copy it from here and paste the code here, change the CRLF to LF. So actually ownable file gives you the constructor regarding the owners. Okay, whatever may be the contract address, that sets that address will be set to this owner, right? Okay, so all these things will be set out here. So these things you can use here as it is. If you don't need some things, those are extra in this file, those you can also cancel out those things, because not all the functions we require, and if you keep those things in your smart contract, sometimes they will give you an error, and for that if you don't like some functions to use, please delete those functions from this file. Okay, so just like I have done that. Okay, sorry, but I think I will need that function, I think so, because it is giving me an error below. So because I will need these things in this functionality. So okay, let this file stay as it is. So this is the ownable file which will set your message.sender address to your owner when this constructor calls, and some things like that. Okay, and such things like this function, it will return the address of the owner. So all these functions we will require sometimes to
run this contract, because we need to check whenever we mint the token, that time we need to check that a token should be minted only by the contract owner's address, or no one else, or no address will able to mint those non-fungible tokens. So that is the thing. That's why we use these ownable files, right? And after that, what we need is to generate all other things and all other files. So we will generate those files in the next lectures. So right now, thanks for watching. Hello everyone. So in the today's lecture, we are continuing with our smart contracts that we have working from the last lecture, right? So now we have safemat.solidity and enable.solidity files in our project. Now what we have to do is that we need to create an interface and the smart contract for the ERC 875, and for that I need to create one file again. So just create ERC 875 or whatever may be the name that you want to give. Okay, and in that file you need to write down that 875 functions, okay, that we have already seen in the remix. Okay, so you can go to google.com and find the GitHub pages again, and these functions you need to define. So actually we are not using all these functions in this smart contracts, because we have already tried and tested all these functions in the remix. So I'm just going to show you how you can write down the smart contract functions or the ERC 875 smart contract functions in a single file, and then that import that file into the another file. So that is the purpose of this thing. Okay, so for that you can copy these things from here also, or what you can do is that you can go and write down the code. So I'm going to write down the code. So first of all, the compiler version, so pragma solidity upper arrow 0.4.23, okay, or 24, whatever you want to use. Okay, yeah. So let's use 24 and write down your smart contract ERC 875, and in that contract write down your functions. So I will write down my event first. So event transfer, and it will take 3 parameters. So first is the address, indexed, from address indexed to, and token array, that is your event to 56, underscore token ID, and some functions that you can copy or you can write down. So just function like balance of pass the address of the owner, or the address, a particular address. For that you want to check the balance, public view, it should return us the balance. Balance, right? And some function like owners of, sorry, yes, function name. So owner
of uint 256, and in that token ID so just change this to here view, and it returning the owner's address, so address of the owner, and we will write down one more function, that's it. So function transfer address of the buyer or the address of the two, and uint 256 is the token that you want to transfer, that is token ID, and I'm making this public. So change this to LF, I just write down these functions for the smart contract, but we are not using all these functions in this front end. Okay, just I want to show you that how you can write down this function from here. Okay, the standard functions that have been given by this ERC 875, and those you can write down in some one file, and then you can import those functions into another file. So that's it with this ERC 875 solidity. Okay, but we need to implement if we need to work with these functions, then we need to create another file. Those will implement these functions. Okay, and in that file we are actually writing down the generic functionality, okay, for this standard ERC 875. So for that I need to create another file, and I'm going to give it name of the file 875, that is token.solidity, and in this file I'm going to import all those things that I need from other contracts. Okay, this is the generic file in which I'm going to implement the required functionality, and this is my main file, you can say. So for that first I need a compiler version, so solidity 0.4.24, and it will always give me an error of the editor, so just change this to LF. Okay, and I need to import this file, so import this, so ERC 875.sol, and I also need, or if you need save.math solidity, then just import that, but I am going to just show you how you can import that file also. So this is how you can import the files or other smart contracts into another smart contract. So save math.sol. So this is how we import the smart contracts and the functionality from other smart contracts to another smart contract. And in this file I need to create my smart contract, my contract. So write down your contract like ERC 875 token and pass the ERC interface here 875, and in this file, so if we require NCF math, so actually in this program we does not need the safe math functionality, because we just are minting the things. Okay, but if any of your programs in the future, if you want to use this safe math and do some mathematical operations on in your solidity contracts, that time how you can use this file. So for that you need to write this using safe math for event 256, and this is how you are going to use this safe math file functionality here for that particular smart contract. Okay, so I'm using this math for this u integer 256, and after that I need to declare some variables like uint public total tokens. So the amount of tokens, the total amount of tokens I will store in this variable. After that I need some mappings. So mapping event to 6. We have already seen the how to use mappings and what is the key value pair functionality in mappings. Make it public. Owner. So here's an error, so remove that actually. So properly write down your syntax. After that I need to write down another mapping. So mapping that is for own tokens. So from this mapping I will get the list of own tokens for that particular address. So for that address event 56 on tokens, and another mapping. Okay, that is mapping from token ID to token index of that token owners list. So mapping event 256 256, make it public. Owned tokens index. Okay, so I am just done with my mappings and the variables now. Okay, so now I need to check that only message sender or the owner of this contract address, okay, can only mint the tokens, and for that I need to check, and I need to check the functionality that only message.sender is able to mint the token. Okay, and token validation, so its ownership belongs to that particular message.sender, right? So for that I need to write down the modifier, because I am going to use that functionality. So modifier only owner of and 56, pass the token ID, and in this require. Okay, so require is like your if else statement. You need to pass the condition here. So my condition is that owner of token ID is equal to message sender's address. Okay, so this is my condition here. So let me check with this error. So what is it? Is yes, okay, sorry, it is a modifier. Okay, so it is giving me an error. Undeclared identifier. Did you mean owner of? Require owner of. So let me go to my ownable file and check here. So in only owner I need to change it here. So let's remove this. Require and make it message dot sender equal to owner. So another error I am getting, so let me check with this also. So if you got an error, try to change the compiler version. So still there is an error, I need to check it out. Okay, what is the problem with this? So I will come back what is the error and I will tell you what was the error is all about. Okay, I find out that this is not a problem here. So undo the changes that I have made here, because here is no problem. The problem is with my spelling mistake, because this is the thing that I have mentioned here and here is the spelling mistake. So just do that and your error will be gone. So such a mistakes would happen while you writing the code. Okay, so look out for these problems. And after that, what I need to do is that I need to write down my total supply function that I am not actually using here. Okay, but anyway, how to write a total supply function I will show you. So function total supply and it will return just the total tokens. So public view returns your tokens, so it will return total tokens. Sorry, I forgot to put this in this function, curly braces. And after that, the main thing that we need is the mint function. Okay, so for that I need to write down a mint function. Okay, so which will mint the tokens for that particular address and transfer that tokens to that particular address. So for that I need to write down the function. So this is the main function that we are going to use, that is a mint address to event 256, because I don't know the length may increase, and token ID, and make it external. So in this mint function, what I'm doing is that I'm minting the tokens, and those tokens ID will be generated, and those tokens ID will be assigned to that particular address, that is the owner of that contract address for our example, right? And after that, I need to check the total length of the tokens that I am getting. The total tokens is equal to token ID and its length. And after that, I need to pass those tokens to that particular token address, right? So I need to use this own tokens, right? Because I'm mapping the addresses to the tokens. So owned tokens, pass the address that is of the 2, and in our example the owner's address, and pass those token IDs that we have generated. Okay, and after the token ID and address pass, you need to transfer those tokens to that particular address, and for that you need to use this transfer function, transfer. Okay, so we need to give here the from, so it is always should be from 0x0, that is uninitialized address, because we are minting the tokens. Those tokens are not coming from any address. Okay, those those are actually coming from the uninitialized address. That's why it is a 0x0 for this, and it should be transferred to the 2, right? Because address of the owner, that is 2, or whoever with the minted those tokens, and the token ID. So all these things are okay. So this is the main function that we are going to use for our gradient token file, okay, from which we will input this function from there, and we will mint the token. So in the next lecture, we will write down another smart contract in which we will pass the color code or whatever you want to pass to this generic ERC875 token interface or this smart contract, and according to that your output will be generated. Okay, so in the next lecture we will meet. Thanks for watching. Hello everyone. So in the today's lecture, what we are going to do is that we are going to write down some test cases for our smart contracts for this gradient token, and for that we need to create the test file in the test folder. Okay, the Truffle has a very good testing framework inbuilt because it uses Mocha and Chai for their test scripts, right? Okay, so all the files that we are going to use in this test folder, those are all JavaScript files or JS files. So to write down the test scripts, we need to create a file in this test folder. So give it a name, gradient token test .js, and this file we will run, and we will write down the code in that. Okay. Truffle, and what is the structure that the Mocha or this truffle actually supports. Okay, so for that I need to first explain you some of the functions that we are going to write down in our project for the testing things, right? So first thing is that what are the functions that are supported by this truffle testing framework, right? So let me write down the functions and their purpose here. Okay, so we are going to use IT, that is it, and its purpose is to run a test and make an assertions. Okay, after that we are going to use describe, which groups its statements. So whenever you have many its statements in your test cases, okay, that time you can use, and you have to use this describe function. So it groups together all the it function, and third one is a before each. Okay, so it executes some of the general setup code. So execute some general needed or setup code, you can say. Okay, so these are the functions that we are going to use in this truffle testing framework. Okay, so it is used to run a test. So whenever you have to check some contract function, that time you have to use this it function and write down the testing code in that it function, and then it sorry, I think here is the ms dog, and after that it make an assertions on that. So we need to describe this it function in the test. After that, if there are too many it functions in your test, that time you have to use this describe function. So it just groups together all the it functions, and before each function is used when you have some code that need to be initialized or need to be set up before each test. That time you can use this before each function. Okay, so now I am going to show you some just basic example that how we are going to write down a test. Okay, that is not a real test. This is just an example that I am going to show you, so you will get an idea how we are going to write down the real test for this smart contract. So let me enter here. So here now I am going to write down example class. Okay, so if I mentioned a class, okay, class like a car, and in that I want to test a park function, okay, which returns me stopped, and another there is a drive function that I also wanted to test, and it returns me vroom. Okay, so now I wanted to this is my class and these are my functions, and I wanted to test this functions, whether or not they are returning the same result that I wanted or that I mentioned here, or they are making some another result. Okay, so what in the testing, what we actually check is that the result that we wanted or that we have mentioned and the result which is generated by the code is the same or not. So that is the assertions that we need to make in the test, right? So this is just a class. Now I have to write down test cases for this. Okay, so for that I am going to use this describe function. So describe and in describe function I have to mention two parameters. Okay, first is the comment that will describe you okay, which thing is executed, and so it will just for the reporting part. Okay, so whatever you may want to add up here, you can add up. Okay, so for example, I can add up like a car or car test, something like that. Okay, so if I put this like a car test, then I can say here like that. Okay, and after that I need to give the second parameter, and that is the arrow parameter that I am going to give here. Okay, so that is the syntax for this is like this. Okay, and after that I need to mention the test code in this. Okay, so as we have mentioned earlier that we always mention the testing code in it function. So I need to write down it function here. So it, and it also takes a two parameter. Okay, first is the comment parameter. You can put anything here. Okay, so I say like car park, or can I park. Okay, and after that also I need to put the arrow parameter here. Okay, and in that I need to mention the code. Okay, so for that I can assert here. Okay, so assert equal car.park, and I am checking with this value, that is stopped. Okay, so what is I am checking here is that I am checking that whether the code generated thing or the result is the same that I wanted in this lecture, or I wanted in this assert is the same or not, right? So if I run this code in a Mocha or in this Truffle, okay, but we are not running this code right now. Okay, this is just an example. So I think if I run this code in Mocha or in Truffle, so it will give me or it should return me this top stage, right? And if it is it gives me some other results, okay, in this parameter, and this thing is different, okay, then that test you can say it is a fail one. Okay, so it fails because the code generated thing or the result is different than what you are expected here, right? So also before this I need to call this class, because the class is outside of this describe and it function. So I need to make a variable for this, that the initialization of the class, right? So new car. Okay, So this is just an example. It is giving me an error, something like that, but I am just showing you how we actually write the code for the tests, right? So it is not a real code. Okay, after that I also can write down the code for the same, that is for the room function. So I am just going to copy this and paste it here. Okay, and I'm checking that room. Okay, and okay, so this is the way by which, okay, let me change this also. I need to change this drive. So okay, so in this thing we always assert that whatever may be the result should be equal or not, and upon that our test is either pass or fails, right? So we have seen these two things in this file. Now I am going to show this before each function. Okay, so when to use this before each function. So whenever you have a code that need to be initialized, or that you need to run before each statement, okay, that you can put in that before each statement. Okay, so for that you can write the code like this. Okay, so before each I am passing this arrow parameter here, and in that I can say something like that, log dot e or something like that, and logs. Okay, so how actually this before each function runs, right? So whenever you run this file in the truffle, okay, so whenever you run the test one by one, so before each test, okay, this file or this log will be run before each test. Okay, like that this will run, okay, first, after that this will run, and again this will run, and after that this will run. So this is the flow of this before each statement. Okay, so in our example here you can see that we need always this initialization of the car, so that we can use here. Okay, so we can remove this and put this here, and we can remove this and put it here. So whenever you run this test, so what this before each do is that it always initialize this car class before each test case or each statement, you can say. Okay, so another thing that you have to think is that if you are going to run this code in a truffle, it will give you an error of this car variable here. Okay, because it is not defined in this function or in this describe, so it is not accessible by this car variable. Okay, because it is outside of the scope, right? So for that what we can use, that we can remove this constant. Okay, this is the constant. So when we use a constant variable, so whenever there is a no value change for a particular variable, that time we can use a constant. Okay, but if the value of the car it change for each iterations, okay, so that time you have to use let keyword. So you can use let car keyword. So here each time the value of the car changes, and you can use that value by using this let variable car. Okay, so this is how actually we write down these functions here. Okay, so okay, sorry, here is the problem. Okay, so this is how we actually write down the test and things for this. Okay, so So by this way we are going to test the code or the smart contracts using the test cases that we are going to write down in the next lecture. I should have to mention here that in the test cases we also going to see this functionality called async and await. Okay, so it syncs the things. Okay, its name is async. Okay, but it syncs the proper things, it syncs the proper code for your test cases and wait for the particular things to be happened, and after that it will run the next code. So this is also the things that we are going to see in our next lecture. So in the next lecture we are going to write down the real test cases for this gradient token. Okay, so we will meet in the next lecture. Thanks for watching. Hello everyone. So in the today's lecture we are going to write down the test cases for our gradient token smart contract. So let's get started. So first of all, define the constant, and in that we need artifacts. Okay, the gradient token solidity, gradient token. Okay, after that write down a contract, and in that your string any message, that is a gradient token. And now your things. Okay, so first of all I am checking with accounts. So this is the syntax for this, and I need to write down it, and in that give whatever string you want to give. Should make first account and owner. So in this test I am checking that whatever may be the first account, that should be an owner, and for that I am going to write down test. I am writing down an async function, then right arrow character, and in that I will wait for the gradient token to be deployed. So I will await for gradient token to be deployed, and I will save its instance in the instance variable using let keyword. Okay, and just like the same way I also await for owner's address using this instance. So instance dot owner, and I will save this also in a variable of owner. And then I will assert between them using assert equal their values. So my account that I am checking is the account 0, so that is the address of the first account that I will get in this position, and the deployed contract's address will be saved in this. So I will check the both addresses, that this, if they are equal, then my test case will pass automatically, or it will get fails. Okay, and just like that I need to write down the test cases for the mint also. So for that I'm going to write down a describe, which will group this it function. Describe, and that write down a mint, and in this define for your first it. So here I am going to check that the created token should have the specified inner and outer colors, right? So create a token with specified inner and outer colors. Then I am going to use async, and in that I will first again check my instance should be deployed, so the same code, and I will also wait for the here is spelling mistake, I need to correct it. Owner and owner, sorry, it was a spelling mistake. So after that I need to check with my specified inner and outer colors that I am going to pass here. So I will await for the instance of mint, and now I am going to pass the 6 strings with the fixed color. Anything you can pass it here. Okay, 0043 any string you can pass. Okay, and I will save this in the let token variable. Okay, after that I need to check for the owner, so I will await for the tokens of particular owner. So await instance dot tokens of owner, and I also save this in some variable. So let tokens. After that I need to check with get gradient instance. So I will declare a variable gradients and await instance of get gradient and pass your tokens 0 at first position, first token. I will wait for the first token, after that for the second one, and after for the third one. Okay, and I need to assert this with my computed result and these results. Assert deep equal and these gradients, and I have this. I need to pass this first two colors. Okay, just like for the assert, check assert for the second gradient, and then here for the third. So this is your first, second, just change the color. Okay, and close this let, and again write down that only owner allows to mint, so you can write down the test case for that also. So allows to mint only to owner, so owner should able to mint only. Okay, and okay, first I will check the same line. The contract should be deployed first, and after that let other, I am saving the other address, that is account one address. Okay, this is the first account, not the owner's account, and I will await for okay. So now we will run this test case using the terminal, and we will see whether we are able to pass the test cases or not. For that, going to deploy our test JS file, and for that we need to deploy the deploy script for this, so that we need to write down into the migration folder. So for go to the migration folder and create a new file, that is deploy contract.js and in that file copy from initial migration and paste it here. Okay, change to LF, and okay, and here just change migrations.sold to the gradient token. Okay, change these all values. Okay, so now we are ready with our deploy contract.js. okay, after that we need to go to this truffle.js file, and we need to add the network configuration here, because whenever we create a project using truffle init, the file is empty, and for that we need to go to the Google and go to this website, that is a truffle framework docs truffle reference configuration, and here you'll find the things. Okay, just okay, now you go to this truffle, then go to the creating project, and in this click on this configuration file and copy from this network to end and paste it in your truffle.js. Okay, and then start your ganache. So I started my ganache here, so this is my ganache opened here. So after that I need to go to the terminal, so I will click in this blank space and open in terminal, and I need to run this command, that is truffle compile. Press enter. So this will compile all our contracts, and it will create a build folder. Okay, after that I need to write down this other command, that is truffle migrate. Okay, now my contract has been deployed on this address. Okay, now we will run this test using the command, that is truffle test. So here you can see that all the test cases were passed. Okay, so this is how we write down the test cases, and how this is how we test the test cases for our smart contracts in the truffle. So thanks for watching. Hello everyone. So in this session we are going to look at the front-end technology that we are going to use in this project. So in this project we are going to use React.js for our front-end development, and using this front-end technology we are going to connect with our backend, that is our blockchain smart contracts. Okay, so whatever may be the technology that you are familiar with in the front end, you can use that technology, just like AngularJS or vanilla JavaScript, something like that. Any technology which is available in the front end that you can use to interact with the smart contracts. So that is your choice to choose the particular or perfect technology for your front end. But for this project we are going with this React JS framework. So let's get started with some commands and some things. So first of all we need to install some React things to work with our projects. So we need to create a React app. For that I have to install this I have to use this command, npm install -g create React app. So just copy that and paste it in here and press enter. Okay, so this will install the React app globally in our system. Okay, now it is installing, as you can see. So now it is successfully installed here. So after that we need to run this command also. Okay, that is only create React app. And the folder name is a front, or anything that you can use. So after first command a successful running of the first command, then you can run this command. So this will also fetch some data from internet, and it will install some folder structure, some files in your project. It will take some time actually, because it's a little bit of heavy. So I think it will take 2 to 3 minutes. So we will continue this after the installation. So now here you can see that our folder structure is ready and it is installed properly. It is okay. So now we have to go to our folder structure, and we can see that here the front folder is created, and in that some folder structure is also created. So in that folder structure, as you can see that there are some node modules. Okay, after that this is a node module, and these are some libraries that is it is fetched from the internet. After that, this is the public folder, and this is the source folder where we are going to create the folders, the component folders and other folders that we are going to work on that. Okay, and after that, this is the package.json. That is a very important file in this. So if you open this file, here you can see that after the creation of this all the scripted and dependencies have been already downloaded or present here or installed here. Okay, but we need to install the MobX, because for this project we are going to use MobX React. For that, we need to go to this command. Before that, we need to do this cd command. Okay, we need to go to this front folder by using cd command. So go to this cd front, and in that just run this command. So I'm going to copy this, that is npm add mobx and things, and just paste it here and press enter. Okay, so it will download and install the MobX React files and scripts that we needed for our project. So, and the truffle contract also. So it will take some time. Okay, now it is successfully completed the installation. So we can go to that package.json folder again, and here you can see that the MobX and truffle contract things are came up here. Okay, after the installation. So after that, we have to create some folders that we are going to use. Okay, so first folder is that our components folder. So just right click on that and create a component folder. Okay, after that we need a contract folder also. And after that we need to create a stores folder. And after that we have to create also that is a tokens page folder. And after that the utils folder, the last one. Okay, so actually these 5 folders we need for our project. So like if you are familiar with AngularJS or React.js, as you may know that we have to write down the components first, like buttons, models, something like that. that we can use through all over the project. So the components folder will contain the buttons, models, and whatever may be the reusable components. So we will put that code into this components folder. Okay, after that there is a contract folder. Okay, on this contract, in this contract folders, okay, it will contain JSON files from this above build folder. Okay, so here you can see that that there are some JSON files that we have we got from compilation of our contracts. So whenever you build a front end and you wanted to interact with your smart contracts, that time front end technology cannot directly access the code of the smart contracts, and for that we need to these JSON files, and we need to copy these files from this folder, and we have to paste those files into this contracts folder so that we can interact with this. Okay, and after that there is a third folder, that is a stores folder. This actually used to store observables like token instances, tokens owner, state of loading, like hide and show and body, like things like that. After that there is a token page folder also. So it contains list of tokens to view single tokens and list of tokens which are minted. And after that there is a utils folder which will actually contain the Web3 provider. So Web3 provider we will use, and that is the main library of the blockchain or the front-end technology, which will help to interact with our smart contracts. So this util folders contains this Web3 provider, and it also contains the contract instances. Okay, and in for this project we have also going to mention the random color logic to generate the random color values. Okay, so all these folder contains some different files that we are going to see in the next lecture. Thanks for watching.
Hello everyone. So today we are going to cover a little bit of basics related to web3.js, what is actually web3.js and why we require web3.js. Okay, so first of all, this is the JavaScript file, okay, that we will required to interact with the blockchain. Okay, so everyone knows that Ethereum is a node based system, right? So on every node there is a copy of a blockchain, right? So whenever you have to pull up some information from the Ethereum blockchain or from that particular node, that time you have to query to that particular node about that data. Okay, and because of that we need to write the queries to pull up those data. Okay, but Ethereum nodes only speak a language called JSON RPC. Okay, they don't speak a JavaScript language or any high level language. Okay, so they speak JSON RPC. Okay, so here you can see that this is the JSON RPC code that I have mentioned here. Okay, so as you can see that this JSON RPC code is not a human readable. Okay, it is a very complex code that we cannot use to pull up the data, because we cannot write such a data. That's why there should be another way so that we can interact with this nodes, okay, or this JSON RPC. So because of this problem, actually whatever maybe the problem faced by the developers, they developed this web3.js JavaScript. Okay, it's a JavaScript which they use to interact with this JSON RPC. Okay, so web3.js hides these nasty queries below the surface, so you only need to interact with the convenient and easily readable JavaScript interface. Okay, so you can only have to write down the code in a JavaScript. Here you can see that this is the JavaScript code. This is a very human readable, and you can do this coding by yourself also. It is a not complex one, and there is a not too much amount of data here. So this is like a URL to the
remote web server for your API calls, okay, in a traditional web app. Okay, so everyone knows that if we develop an iOS app, okay, and whenever we want to interact with some server, we need an address of the server or web APIs. Okay, from those web APIs we can pull up or send the data to the particular server. So just like that, this web3.js actually help us to get or send the data, or it will help us to interact with the Ethereum blockchain. Okay, so but how we are going to talk to the Ethereum based blockchain or that particular data? So in the last lecture, I think so, we have seen that the folder structure and how we are going to install this front folder and all that stuff we have seen in the last lecture. In that folders also, there is a one particular folder that we have made, that is called the contracts. And what we have done in that contracts folder, that we copy some JSON files from the build folder that we have compiled earlier, right? And we have copies those JSON files, those we got after the compilation, and we copy those file and paste that files or those JSON files into our that contracts folder, right? So why we did that? Because those are all ABI's files. Okay, so as I mentioned that there is a JSON RPC thing, okay, and we cannot interact with the JSON RPC directly, so we need an ABI to interact with the data. So because of that, we need ABI, and then web3.js will talk to this ABI, and then this ABI will talk to that particular blockchain. Okay, so this is the flow of this. Okay, so basically it's as I just mentioned, it's a representation of your contracts. Okay, that is a solidity code, but that solidity code gets converted to .json format, and that JSON format you can understand. Okay, after that there are many numerous things by which you can interact with these Ethereum nodes also. So some of the ways are like, you can write down the code in your or that script in your project, and you can interact with that particular node also. Okay, or you can use things like MetaMask or third-party tools like Infura or something like that to interact with this Ethereum nodes. Okay, so also that if you want to talk to this blockchain nodes, that time you also need the port numbers, right? For Ethereum main blockchain or for the test RPC, you have the port 8545, and for the Ganesh you have the port 7545. Okay, so and the main thing here is that your blockchain node must be running to talk to that node, because if blockchain or that particular machine is off, then you cannot talk to that particular blockchain using web3 or any ways, right? So this is the thing. Okay, so let me tell you about the tools, okay, of this. Like I told you about the MetaMask, so you can go to this Chrome store, web store, and in this web store go to this extensions. In this project we are not using the MetaMask for any of our transactions. We are going to directly use our scripts in our code, but many of the applications in the future that we are going to build, or you can see on internet, you will find this MetaMask thing. So just find this MetaMask. Okay, and just click on this MetaMask. So here you will find this extension, and yes, just you have to install this. I have already added this MetaMask here. Okay, so this has just an accounts. You have to give your passwords, and they will create the accounts on the MetaMask. So this is the Chrome based or Firefox based extension that you can use to interact with the blockchains. You does not need to code anything or something like that. This is the third party and very good tool which is developed by this metamask.io. So this is very helpful tool that you can use. After that, there are some also subnet of the Ethereum, like Infura, that you can use. Okay, let me show you. So this is the scalable blockchain infrastructure that you can use for your Ethereum based projects. Okay, so many of the time what is the problem that people get is that if you want to actually run or download the actual Ethereum main node, so that time you will get the problem of syncing, because the main Ethereum node is actually very huge. I think it's probably current size of the Ethereum blockchain is around 70 to 80 GB, okay, gigabytes. So that is a very huge, and so people will get very tired, and they get very bored because of the sync problem between your nodes and the main node. So many of the time people actually go for this Infura. Okay, so by using this thing you can also able to interact with the main node. So this is a free thing, so you can go and just inject their one line of code into your project, and you will be able to interact with this. Okay, so in the next lecture we are going to use this web3.js to interact with our contracts. So we will meet in the next lecture. Thanks for watching. Hello everyone. So in this today's lecture we are going to get some coding part here, okay, for the front end. So for that we need to deploy our smart contracts on the Ganache test address. Okay, that is a 0x something. Okay, here you can see this is the transaction ID that I got, and this is the address, okay, that we need to copy, because this on this address actually our smart contracts is deployed. And in the earlier lectures all we know that we get the address back from the after deployment. Okay, so this is the address where my smart contracts is now been deployed. So I need to interact with this address. Okay, so I need to copy this and paste into my code in the new file called addresses.json. okay, so in this file I am going to paste that address, the deployment address. So I need to write down token addresses. Okay, and I need to paste this. Okay, now I have pasted this address, so on which our contracts has been deployed now. And after that what we need is that we need now the provider, okay, which will interact through this ABI ABI that we have already pasted it in this contract folders, different types of JSON files. Those are all ABI files. Okay, so now what we need is that we need a provider. So in the earlier lecture what we have seen about the provider is about web3.js. okay, so that web provider we are going to use. So I need to create a get provider.js file in this util folder. So I am going to create this file, so that is get provider.js. okay, and in this file I am going to import the web3 library. Okay, that is our in MobX. So this is the code for this. You does not need to install this Web3 library separately because it is already present in our node modules. So just import that, and after that define a constant variable get provider. Okay, to this web provider we need to assign the URL, Web3 provider URL. This is the right arrow, and in this I am going to return the my localhost Ganesh's web address. So the Web3 will get to know that how to interact with the Ganesh. So just write down the HTTP localhost. So this is the address that you need to copy. Okay, make the changes some and put the semicolon after that. Okay, and export this get provider. Okay, this is the React import export function. So export default get provider so that we can use this get provider variable in the other files. Okay, after that as we know that in our project we actually making the tokens based on the random colors. So for that we need to write down some code to generate that random color, and for that I need to make another file that have that logic about this random color. So just create the random color.js file in utils. So just random color.js. okay, and in this file you need to write down this logic. So just write down export to default function, and the function is a random color. So default function random color, and this should return the random color logic. So I'm going to return first. I also need the hash because as you know that JavaScript takes colors in hash values. So in that I need to implement this math function. So math.random, okay, multiplied by this 0xFFF. So this is just a logic to create the random numbers each and every time. So we will get a random minted token with different colors, and that we can saw on the front page. Okay, so you can also write down this as it is, or you can change. There are lots of random color logic present on internet, so this is one of them. Okay, just 16 here and semicolon, just give that and return this value. So just I have to show this to you how actually this random color logic works. So I'm going to copy this code and paste it into my Google Chrome console. So just press F12 and here you will find the console. Okay, and I just pasted here, and you will find that this is the color, okay, with the hash value appended. Okay, so each and every time I am getting different type of colors. So this is how you can check this function on Chrome browser. Okay, and okay, so we have done with this random color.js now. So after that we need a gradient contract instance. Okay, for that I need to create another file in the utils folder, that is a get gradient contract instance.js. truffle.js. Okay, so in this file I am going to import truffle contract, the provider which will help us to connect with this smart contract code. Okay, after that we need an gradient artifact. Okay, that is an ABI that we need to interact with the smart contract code in Solidity, and addresses.json where our contract has been deployed. So write down this import functions. So import contract from truffle contract. After that import get provider from utils. Okay, get provider okay. After that import gradient token artifact. Okay, so this is the JSON file, okay, which has the ABI. So write down the code for that also. Okay, and after that the fourth import, that is addresses from addresses.json. Okay, this will has the address of deployed contract. Okay, and after that I am going to use a constant array of token addresses, and I am assigning the addresses here. And after that I need to write down another get gradient contract instance using this export default function present in React. Okay, so this will give me the gradient contract instance through which I can communicate with the blockchain. So this is the code I am writing here. So now I have to define the constant variable again, that is a gradient token contract. Okay, and in that I'm going to get this gradient token artifact, which is the actual ABI file or ABI code through which I'm going to communicate. Okay, so just pass on this gradient token artifact and give semicolon, and after that I need to set the provider using gradient token contract dot set provider, and just pass the get provider value that we have imported above. So this will set this provider to that ABI. Okay, and after that I need the contract address or instance. So for that I am going to write down a variable, constant variable, that is constant gradient token instance. Okay, and I am going to await. Okay, and write down a gradient token contract at token addresses. So this will return the instance of the gradient token from that particular token addresses, and I have to just return now this gradient token instance. So just return gradient token instance and give semicolon. Okay, so this is the code to get gradient contract instance and all the stuff. So In this lecture, what we have seen about about the provider and random color logic and addresses.json. So in the next lecture, we are going to write down some components code. Okay, so we will meet in the next lecture. Thanks for watching. Hello everyone. So in the today's lecture, we are going to create some more JavaScript files that we are going to use in our project. So now we have a utility function to get the contract instance, right? In the last lecture we have seen that. So let's use the MobX store to store that utility function. For that we need to create a contract store.js in the stores folder. So just create a new file. Okay, contract store.js. Okay, in this file I need some functions from MobX, like observables decorate, that I need to import. So just write down the code for that. Okay, import observables decorate action. Okay, for the more documentation and for the more information, you can search what is observable decorate and action in MobX. Okay, because in this project we are not explaining the all React functions, or we are not covering the React. Okay, after that we need the get gradient contract instance. Okay, so we need to import that. So write down the code, import get gradient contract instance from utils / get gradient contract instance semicolon. Okay, so after that I need to write down a class, that is class contract store. So first of all, in this class I am setting the gradient token instance with the value null. So whenever we call this contract store.js, we will null the value of gradient token instance. Okay, and we will set it to the null. Okay, and after that we will set up the gradient token instance. So need to write down the async setup function. Okay, for that, before that we need to set gradient token instance first. So write down the code for that. And in this code we will get actual gradient token instance, and we will set to this get gradient token instance. As you see here, I am setting this, so it will set that gradient token instance value in this function. And after that I need to write down an async setup function. Okay, so this is the code for this. So I write down this dot set gradient token instance, and I need to wait for get gradient contract instance. Okay, and after that I need to export some decorate values. Okay, so this is the code for this. I'm not too much explaining this code, but I'm just exporting the observables and actions here. So write down this code. So gradient instance observables and set gradient token instance action. Okay, so the only function of this store is to have an observable reference to gradient token instance. Initially it is null, but after setup method is called, it gets the instance using our get gradient contract instance utility function. And gradient token instance is observable, so we can derive changes from it in other classes. So let's create another file called model store.js. Okay, so write down the code for that. So import observables action decorate from mobile. Okay, so this file is I'm going to use for just like to show model like body or hide model like show or something like that. It's this code you can copy and paste also. So I have to write down but here. So model is equal to write down show false and body null first of all. And body null. After that I need to write down a show model. So write down show model equal to body arrow character and open your curly braces, and in that write down this dot model dot show is equal to true semicolon, and after that this dot model dot body is equal to body semicolon, and after that the same the hide model you can copy and paste just here and just change the name here to hide model and just make the model show false and the body value is null. Okay, and we need to export these values using decorate. So model store comma curly braces open, and in that write down model double colon observable, after that show model action and hide model. Okay, so in the next lecture we will see how to use this model store.js file and contract store.js file in another file. So thanks for watching. Hello everyone. So in the today's lecture we are going to create another Embark store file, that is a gradient token store. So just create that file. Okay, so this token file or this token will be responsible for accessing contract methods. Okay, so we need to code some things in this. First of all, we need to import observables, actions, decorate, computed, and when from Embark. So just write down this code, computed when from Embark, and after that we need to import this random color file from utils. So just import random color from utils / random color, and after that we need to describe a class that is a gradient token store. In that I am taking a blank array, that is tokens, that is equal to blank array. After that I need owner, that I am setting its value to null, and we are going to use isLoading method, and that is I am setting it true. Okay, after that we need to write down a constructor, okay, which will run after deployment of this contract, and in that I need to pass a contract store which we have created in the last lecture. So just write down this code and pass the value, that is this dot contract store is equal to contract store, and use when this dot gradient token instance, this dot setup, okay. First of all, I am writing down the code and I will explain it a little bit after writing down. Okay, and now the get gradient token instance, write down the code also for that. So get gradient token instance, okay. So let's set up a sync function. Okay, that we will need to set up an owner and contract store to the gradient instance array, but we will write that code after some time. And after that we need to export the default decorate values here, and that we will write, that we will also write in the next. Okay, so here we defined the gradient token instance getter and made it computed. Okay, and Embark allows to observe observables automatically and create computed values based on them. And if you want more information about MobX, you can go to Google and find it. Okay, and we observe this property in a constructor using when also. So once gradient tokens is set up, we call the setup method. So we write down, I need to set up the owner's address in this setup method. So just write down the code for that. So constant gradient token instance, this dot contract store. So in this function I'm going to set the gradient tokens address that we get from gradient token instance dot owner, okay, to a new method called this dot set owner, but I'm going to write down the code for this set owner after some time. Okay, so you can go and write down the code for that also. So just write down a set owner, pass the owner value here, and just assign this dot owner is equal to owner. Okay, so now we have a setup function here, and after that okay, so now we need to fetch the token list, and for that we need to add a new function called fetch tokens. So write down the code for that, this dot fetch tokens, and write down the function that is fetch token and use async for that. Okay, after that use a constant variable, say tokens, and await this dot gradient token instance dot tokens of a particular owner, and for that use this dot owner inside of that. So we will get the tokens of particular owner. After that we need to write down another variable, that constant gradient, okay, and here we are using promises, so we will wait for promise dot all. Okay, so write down the code here. Okay, so as here you can see that first we call our contract method tokens of, and it will return an array of token IDs. Now we need to get associated gradients. Okay, and for that we call the get gradient method for every ID, and in order to wait until all the promises will be resolved, we will wrap all the code that I am writing here in the promise.all. Okay, just write down this code. And return the value. Return this dot get gradient token instance dot get gradient, and pass the token. And after that, after the gradients are loaded, we need to update is loading attribute, and for that I need to write down this set loading method or function. Okay, I just need to set its value to false. Okay, and I need to write down the code for that. Set is loading, pass the value that I have passed as false, and set the value to is loading variable, that is this dot is loading is equal to whatever may be the value. Okay, after that we need to check the condition. Okay, so that is if condition. So if gradients array is not empty, then we can call the set tokens method, and the set token method is trivial. It is just an mbox action that sets the tokens attribute. So write down your if condition. So if that is not equal to gradients dot length, and is return. Okay, so after that, just set your set tokens. So this dot set tokens in bracket, just pass the gradients here, and actually we need the index tokens. Okay, and for that we need to write down the set tokens method first that we have just mentioned above. So set tokens, pass the tokens here, and set this dot tokens dot replace with tokens. So the index token just adds an index to every gradient, and it's needed for React. So we are going to show our tokens in a list, and list elements in a React should have unique key prop. So write down the index token method. So index tokens, pass the gradient here, and write down the return gradients dot map gradient arrow function. Okay, so in this we need to return a gradient and index. So I am going to write down the code for that. So just return your gradient and index. And just increase your token index to by 1 by ++. Okay, and here we need to define this variable, that is token index, and initialize it with 0. Okay, so in the next lecture we are going to see the next functions like minting the tokens. Okay, our mint token function that we are going to write down in this file. We are going to append the token, so, and some other functions. So we will meet in the next lecture. Thanks for watching. Hello everyone. So in the last lecture we have written down some functions, okay, like fetch tokens, set tokens, set owner, set is loading. Okay, in this lecture we are going to start with the new functions. Before that, in the last lecture we have written the method about index tokens, okay, but we have not passed that value to the set tokens. So right now I am going to pass that value using this, so this dot index tokens, and then I will pass those gradients to this, right? Okay, so just passed here the value. After that we need to go for minting. So now we can show that the list of tokens, okay, now we can show the list of tokens, but we can't create new ones. Let's fix it by using the mint token method to our gradient token store. Okay, before that let me complete this index code here by semicolon. So just complete that code using the semicolon here. Okay, so now we'll go for the mint method. So write down the mint method, so just press enter here and mint right arrow and use the constant here. So I am going to write down a constant gradient token instance array, and I will pass the contract store instance to this constant variable. After that I need to pass the random colors excuse me, to the new variable called constant gradient, and I need to pass these random color functions for inner and outer color. So I need to put this. After that I need to mint the gradient token instance, so I will use await then gradient token instance dot mint, and I will pass the gradient okay. So for the important note here is that we call the transaction using HTTP provider, okay, and the transaction requires a gas, as we don't use any kind of wallet here. Because of that we need to calculate the amount of gas, or it will be get automatically calculated. But for our example I am going to pass the fixed value of the gas. Okay, before that I need to pass owner also, so from which owner the gas is coming. So write down the from this dot owner, and pass the gas value for that owners needs to pay, that is a After that, after the minting, we need to export the decorate values. So for that, just write down the code. So export default decorate in bracket gradient store token store, and write down owner here, make it observable. Okay, tokens, also make it observable. After that, is loading, also make that observable. And after that, we need to write down set owner and mark this as an action because it will do some action here. After that, the set tokens, mark it as action. After that, set is loading, mark it as a action, and append token and mark it as action 2. Okay, so this is the gradient token store file. Okay, after that we need to initialize these stores. Okay, we have just written down these stores files, but we need to initialize this, and for that I am going to create a new file, that is index.js, and this is the main business logic for our project. So just create a index.js, and in that file I need to write down some code. So first of all, I need to import all the stores that we have created in this store folders. So like import contract store from contract store, and import gradient token store from /gradient token store, and the third file is the model store, that also we are going to import here. And after that, I need to initialize all these 3 stores. So first of all, I will initialize this model store. So write down const model store is equal to new model store. Okay, after that I write down a constant contract store and is equal to new contract store, and third one is a gradient token store. So in the for the gradient token store, I need to pass this contract store value as a dependency injection. So I have passed this, and after that I need to set up. So just write down the contract store dot setup. So this is the method in that contract store that we are calling. Okay, and after that we need to just export the defaults like model store, contract store, and gradient token store. So all these three stores I'm going to export. Okay, so now in this file we have imported all these contract store and initialize those things. Here you can see. In the next lecture we are going to add components to our project and app.js file. So we will meet in the next lecture and we will see how to add a components and other things. So thanks for watching. Hello everyone. So this might be the last lecture of our project development. So in this lecture I already have copied some HTML and CSS code from my running project, and I have already pasted that code in components and in token pages folders. So here is the just code regarding the HTML and CSS view of your HTML pages. Okay, so here you can see that I have copy and pasted the HTML and CSS code for the buttons. It's event like on click or something like that, and after that there is a models. Here you can see the CSS for the buttons, after that the model and its CSS. Okay, token image and with loader and everything that is required to show these components on a screen, that I have copy and pasted here, because these codes are HTML and CSS code. So everyone can design their HTML and CSS code according to their logic. So I am not wasting the time to write down that code here line by line. So I have just copied and pasted it here, and after that we will go to the token pages here, and here you will find the index.js. okay, and here is also, this is the HTML pages and its CSS, and these pages will be shown to the user. Okay, and here you will see the token list also, and in this token list I have the token item and token view folders. Okay, so this is the things that you can see here. Okay, so just you can we are going to publish this project on the after this video also on the website, so you can go there and you can copy and paste this code for your practice also, or you can find this code in the project documentation. Okay, and after that the main file that we are going to write down the code is the app.js file. Okay, so we will go and write down the code here. So if you open this app.js file, so it is an entry point file for our project. So whatever we have created up till now is we are going to call up here, like stores and after that model and token pages. Okay, so I need to write down some code, and for that let me import some provider first. So import my provider, that is MobX React. Yes, provider from MobX -React. After that I need to import the model also. So import model from /components/model, and after that the token pages. So I am importing the folders and pages from the project. And after that we need to import the stores also. Okay, just complete this. And so I am deleting that logo thing because we are not using any logo for our project, so I have deleted that line. Okay, and here you can see a pre-generated code by default, so that we don't require. So I'm going to delete that code and we will write down our own code. So in this return statement I need to write the provider, so write down the provider. In that provider tag I have to pass the stores with 3 dots, and then I am going to use a div and giving that div a class name, that is an app. And in that div I am going to call our model and token pages. Okay, so in this file we have written the model and token pages with the this div. Okay, and I think we have done with our code. Now we will see and we'll go and we'll check that whether our code will run or not. So for that I need to open the terminal here. So open a terminal and write down cd front, go to the front folder and write down the command npm start. So this will start the npm server and it will, and our project will run on browser. So now it is loading. So here you can see that the gradient tokens and the mint button is there, and here you can see you don't have any token set, right? Because there is no tokens at the first position. Okay, so now we need to create on this mint token button, and here you can see the two color token is generated. Okay, and the inner and outer value you can see here. Okay, after that you can again click on that. So here you can see that the tokens are generating and no tokens are same, means that like not ERC like 20 tokens, they are not same, they are different from each other. And according to our project we are going we have getting 2 colors token here. So how you can run this code? So this is the end of our project. Okay, thanks for watching. Huge congratulations from me to complete this course. So in this course we focus around helping you to become an advanced in theory and in development of a blockchain. In this course we build something meaningful that will really going to help you in your career as a blockchain developer. So in this lecture I just want to run through the project for you, actually what we have covered in this lecture. So in the first session of this project we have covered about the project introduction. After that we covered blockchain and what is a blockchain. After that Ethereum network, what is a smart contracts, solidity. Okay, so those were actually the theoretical lectures that we have explained in session 1. Get introduced to remix ID, and after that we written down some inbox smart contracts. And in the next lectures is that the installation of npm, what is mean by truffle, test framework, we installed Ganache. Okay, after that, what are the variable types supported by the Solidity? Okay, and after that we also check the mappings and struct. After that we install the softwares for our development, and we saw the file structures. We actually started the development of our smart contracts for this project. So first of all, we after that we gone for the minting and other token contracts function. In that functions we also explained many different contracts that was necessary for our project, and we also write down the test cases to check those smart contracts. And in the last lectures we actually built a front end using the React.js, and we connected our smart contracts using Web3.js, right? So we saw the workflows, tools, setups, and other things in the whole project course, and Web3 and other things also, right? So this is the course, and I hope that you will be happy to learn from this course. So just a quick thing that I'm always welcome for, you're all always welcome for review. So if you are happy, please leave us some feedback. Okay, and if you have any constructive feedback having been through this project, please send us a message. I just wanted to wrap up this project now, and remember, I'm always active for discussions or any problems that you get while developing. And should you have any questions going forward other than that, we look forward to see you in the next other projects. Thank you.